Hi and hello dear friends, welcome back once again to our channel Vagai Academy of Mathematics, and this playlist is where you can find video lessons for CBSE class 11 applied mathematics. This session we are about to solve exercise 2.1 from the concept of indices and logarithm, and it is from our standard book ML Aggarwal and Neeraj Raj Jain. This is about this session, and this is based on the concept of indices and logarithm as I told. And if you have seen our playlist, you would have observed the basics of indices in our previous sessions. So I would have given the basic concepts of what is indices and what are the basic axioms, what are the basic rules, laws there used. Everything we have seen there in the previous session itself. If you have missed that video, I will attach the link of that video here in the description box of this video. You can have a view so that you will be able to understand what are all the things and the way how we are going to solve the problems from this exercise. And for your views, I have just written the exponent laws, okay, all the laws of exponents that we are going to use very frequently while we solve the problems. About these are what you can find an introduction in that video part, so you can have a view there. You would have you can see more examples there, so it will give you more clarity in understanding these exponents, these laws and everything. And based on this, we are going to solve the problems here in this exercise 2.1. Yes, we go. Yes, let's start from the first question. Here at question number 1, we have got two subdivisions. We'll work them one by one. We'll come to the first subdivision. Here our question is simplify the following. Like we have got 81 by 16, the whole raised to the power minus 3 by 4. So this is going to be our first question here. So again, we are about to use this axioms, any one of these axioms or the combination of axioms to solve these or to simplify these expressions. Okay, that's what we are going to do here. So listen carefully what we are going to do here. So this will be equal to, first of all, you see you have an expression inside the brackets and that is being raised to a negative power. That is, you have minus 3 by 4. So in this case, what we can do here is we can go see the axiom or the law where you have a negative power. Okay, yes. So see here we have an axiom, we have a law that says a raised to minus n will be equal to 1 by a, that is the reciprocal. We have to turn it to be the reciprocal raised to the positive power. I mean the negative power that will be turning to a positive power. Okay, this is what is happening. So we are going to use that law here to solve this. So listen carefully what I'm going to do. So 81 by 16 is there. So what is happening there? It is getting reciprocal, is it or not? So in that case, it is going to be reciprocal. Reciprocal means it will be like 16 by 81. So whatever we have inside the brackets, that I'm doing reciprocal of that. So 16 by 81, it is going to become like this. And now what happens to the power? Power we already had minus 3 by 4. Now it will turn to positive. That is, it will simply become 3 by 4. Okay, and remember, please don't do any reciprocal process here in this power. Okay, that we shouldn't do. So we are doing that reciprocal process what we have in the base only. Okay, that means the what expression that we have inside the bracket, that alone we are just making upside down, and the power will just become negative to positive. That alone happens. Okay, so we are getting now 16 by 81 to the power 3 by 4. This is what is happening. And what next we can do here? Yes, I'm going to do it something like this. See here, note it very carefully. So we have got a fraction in our power, is it or not? We have got 3 by 4 in the power. So now what we have to do here is, I'm going to write this 3 by 4 in a different way. Okay, just look carefully. So the 16 by 81, I'm going to write as it is, 16 by 81. The whole to the power, what I'm going to do now is, this 3 by 4 is what I'm going to adjust now. How I'm going to do it? Just listen carefully. I'm going to rewrite this as 1 by 4. Again raised to the power 3. I hope you can get this. That is, this 3 by 4 is what I'm just writing in two separate powers, right? Okay, that is 16 by 81 whole power 1 by 4 the whole power 3. This is what I'm writing. You may wonder why I'm doing this. Again, get back here. We have an axiom that says a power m the whole power n will be equal to a power mn. That is, when we have power of power, it gets multiplied and it will become the product. The power will get a product. Okay, yes, power of power, it means it will become 3 by 4. So this step is what I'm just rewriting like this. Why I'm doing this? Just for a comfortability we are doing this. Okay, fine. So this will be equal to, again we'll just see here, 16 by 81 raised to the power 1 by 4. So we are getting a fraction in the power. So that means, again look at this axiom. So a power 1 by n, this axiom says a power 1 by n is nothing but nth root of a. Is it or not? Now we are going to use that axiom over here, so that what happens is this 16 by 81 whole power 1 by 4 will now become, just remember it is 1 by 4, power is 1 by 4, it will become, see here it is becoming nth root, is it or not? So that means this will become 4th root of 16 by 81 the whole power 3. Fine, okay, alright. So this power 1 by 4 alone I am just rewriting it as 4th root. Okay, yes. So now this will be equal to, now just think of what is 4th root of this 16 by 81. We will see them separately. Okay, yes. When you have powers in fraction, so what we can do is we can individually take the powers in the, both for numerator as well as denominator, we can do that. So now just think of what is 4th root of 16 and think of what is 4th root of 81. What do you mean by 4th root? A number which you multiply it with itself for 4 times, what answer you will get. So that is what you call to be the 4th root. Okay, like how we call square roots. What is square root? You square a number or you multiply a number with itself, you get an answer. So which number is that? That is what is going to be the square root of that original number. Same way, here we have the number 16. Now think of which number if you multiply 4 times, you will get this 16. It's simple to say, right? So just start from 1 itself, it will easily tell you the answer. So 1 power 4 will be 1 only. Is it not 1 power anything is going to be 1 only? And come to the next number. Next number is 2, right? Just try doing 2 power 4. What will be 2 power 4? So 2 power 4 will be 2, 2, 2, 2. So you multiply all that 4 2's, you will end up with getting 16 here. Is it or not? So in that case, this 4th root of 16, the numerator part will become 2 divided by, what about this one? Denominator we have 4th root of, again it is going to be 4th root of this denominator 81. So what will be 4th root of 81? Just go for one more number. We try with 3 now. So 3 raised to the power 4, or you just multiply, try multiplying 3 4 times with itself. So you get 3 into 3 into 3 into 3. So that's nothing but 81. Is it or not? Yes. So that means 4th root of this 81 is going to be 3. Yes. So now all we are getting is, for this expression that we see inside this bracket has become 2 by 3. Now again this 2 by 3 is raised to 1 more power 3. Okay. Now this can be done easily, right? Why? Because this is just a cube operation. So 2 by 3 the whole cube. This again you can see separately for both numerator and denominator. How we just dealt with this one, the same way we can deal with this also. 2 by 3 the whole power 3. We can take the power 3 separately for both numerator and denominator. So once we try to do that, we get 2 power 3. So what is 2 power 3? 2 power 3 will be 2 into 2 into 2, which will be 8. So 8 divided by, what is 3 power 3? So 3 power 3 is only 3 into 3 into 3, that will be 27. So your final answer is going to be 8 by 27, and that's going to be the answer for our first question. Yes, okay. So fine. One thing I just want to tell here itself, see, just to solve this one basic problem itself, we are happening to use almost many of these axioms, right? Like this, solving this one problem itself is involving some 3 or 4 axioms to be used from this one. So the point I'm coming to say here is, we must be very much thorough in all these axioms, all these laws of exponents. Only then you will be able to touch and then finish a problem. Okay, so be sure with all these properties, all these laws. This is going to be very important, and once you're very much sure with this, just try to work out some basic examples. You will be very comfortable, you can feel very comfortable in solving these kind of questions. Okay, all right, yes. Yeah, now we'll move on to the second subdivision of the same first question. So we'll come here, this problem. So this is almost like a very similar question only we have. So we'll try to work this question also, but now in a little faster way we'll try to do. Okay, because not each and every time we'll be able to just try to match and then just use the axioms, and then we can't go very slowly. Okay, I hope it will be very clear to you. Fine. For one example I just showed that, and for the other thing we'll try to make the problem little faster. Okay, yes, fine. So if you carefully follow it, you will be definitely able to understand, or even you just pause the video and then just try working out by your own. You will definitely getting the answer also. Yes, okay. Yeah, come on, try. Second question here. So here we got 161 by 64 raised to the power minus 2 by 3. This is our question. So again we are getting some expression raised to some negative power, but this time we are getting a we are getting a mixed fraction here, right? Okay, because this 161 by 64, this is going to be a mixed fraction, right? So how to turn a mixed fraction to be an improper fraction? We have learned in our school days itself, very earlier days, right? So like in our school days, like 3rd standard, 4th standard, 5th standard, we used to do this kind of calculation. So we have to carefully turn this. So what can be done here is, like, this denominator 64 into 1 will be 64. 64 plus 1, this 61 will give you 125. Is it or not? So that means this mixed fraction will now become 125 divided by 64, the whole raised to the power minus 2 by 3. I hope you can understand this, what I'm doing here. So this is this mixed fraction turning like this. 64 ones are 64. 64 plus 61 is 125. So 125 by the same denominator, 64 raised to minus 2 by 3. This is what you have. And now what we can do is, hereafter the same approach what we carried here is to be done here. So again what we can do is, we have a negative power. So what I can do is, I can do a reciprocal and then change the power to positive. So I will do 64 by 125 power 2 by 3. Yes, fine. And what next I can do here is, I can just bring this 3 to inside, like how we just brought this 4 here inside as 1/4, and then in turn that is made as 4th root. Here I'm going to do that step very directly. Okay, so just to save our steps, and just try to do this step very directly. Like this 2 by 3 is there, right? This is like 1 by 3. This 1 by 3 comes inside as what? It will come inside as cube root, right? Okay, so cube root of, it will become 64 by 125. 64 by 125, let me write clearly. So the whole power 2, okay, because we'll have only 2 there, because this by 3 is what came inside as this cube root. Okay, fine, all right. Yeah, okay, yes, proceed. Now cube root of 64 by 125. See the numerator and denominator individually, like cube root of 64 and cube root of 125. It's easy for you to say. So cube root of 64 is going to be 4, is it or not? Just you try the first 5 numbers, first 10 numbers itself, you can easily get the answer, because that is the way we'll be getting the questions also. And I insist you here to be very much thorough with cubes, I mean squares, cubes, and then power 4s, power 5s. For the first few numbers, it is better. It will be better. Okay, right? You can save your time also. So in this case, this cube root of 64 is going to be 4. Why? Because 4 into 4 into 4 you get the 64. So that means cube root of 64 will be 4 divided by, what about this cube root of 125? And this is going to be 5, because like 5 into 5 into 5 will be 125. So you get by 5 here. So 4 by 5 you are getting raised the whole power, what you have 2 here, so it is like 4 by 5 the whole square. That's it. Okay, so again we can apply the square to both numerator and denominator, so that you will be getting your answer to be 4 square, which is 4 4s are 16, divided by 5 square, which is 5 5s are 25. And that's going to be the answer for your second question of this first subdivision. So successfully I have completed the 2 subdivisions of the first question. Yes, let's move on to the second question. This question number 2 with us. Again we have got 2 subdivisions here also. So let's try to work the first question now. So first subdivision here is 3a divided by b power minus 1 plus 2b by a to the power minus 1. So we have got to simplify this expression now. So how can this be simplified? Yes, let's see that. So this is something based on only constants, like here we don't have any numbers here. So these a and b, we can treat it to be some constants here, so no issues. So like what we can do here is, like this is just a play of algebra, but yet we have to use the same laws of exponents to simplify these expressions also. So what can be done here is, like first one we have 3a divided by b power minus 1. This is what we have got, right? So for this one what we can do here is, like we can just take that 3a first, and then this b power minus 1 is there in the denominator, right? So what will happen to it? So when we have a fraction, what we can do it? We can just try to take the reciprocal of that, right? Because a power minus n is going to be 1 by a power n. So in that way, we have got this b power minus 1 that is in the denominator. So what we can try to do here is, we can just bring it to the numerator. And so what happens to the power here is, the power will become negative. Okay, already it is like minus 1. So what is that? Minus of minus 1, it will become just positive 1. Okay, I hope you can get this. Let me just again tell you, repeat it. So we have already got 3a divided by b to the power minus 1. This is all we have here. So the 3a is there in the numerator, no problem. So I am writing the 3a as it is. Now what happens is, this divided by b power minus 1 is there. Like that b power minus 1 is there in the denominator. So what I can do here is, I can try bringing that b to the numerator, but what happens is, according to this axiom, the power, whatever power you have, it will turn it to be exact negative. That's what will happen. Okay, so fine, in this case here, if we have a positive power, it will become negative, but here we have a minus 1, it's a negative power. When you try to bring it, it will become the positive. So that is the reason I've written here b to the power 1. That's it, very simple. Okay. So yes, let me try doing the same thing here also. Why? Because here also we have in the same way. So 2b is there. So 2b, and what happens to this a power minus 1, which is in the denominator? When you try to bring this a to the numerator, it will just become a to the power 1, and this will be nothing but simply this is 3a into b power minus 1, which is b. So this is going to be, when you multiply, this is 3ab plus again here 2b into a power minus 1, and this is going to be a. So this will also become 2ab. So the addition of 3ab plus 2ab, we have to add it, so that we will be getting 5ab, and this is going to be the simplified expression for this first question. Okay, yes, I hope you got it. Yeah, coming to the second question, second subdivision here. So here we have a simple question only, not very complicated numbers. We have got a very simple, we have got simple numbers only. So let's see how can this be simplified. Okay, yes. So we have 5 power 0 into 4 power minus 1 plus 8 power 1 by 3. This is what we have. So this 5 power 0, what about this 5 power 0? So what about our axiom? So what is a power 0? So a power 0 is going to be always 1 as long as a is going to be non-zero. If a is not equal to 0, then a raised to 0, no matter what is the value of a raised to 0 will be always, definitely it will be equal to 1 only, right? Okay, so in that case, this 5 power 0 will be, no doubt it will be 1 into, now what happens is, like, this is 4 power minus 1. So 4 power minus 1 means we can definitely use this axiom, right? So a power minus n, so this is in this form. So I can try taking the reciprocal of this 4, so it will become 1 by 4 raised to simply 1. Okay, why? Because like this 4 I am turning it to be reciprocal 1 by 4, and for that reason what happens to the power will become negative. That is, like, we already had minus 1, that minus 1 will become negative of that, which is going to be positive plus 1. Okay, so 1 by 4 power 1 plus, we have a plus. Next what we have 8 raised to the power 1 by 3. So for this we have to use this axiom, this law. Okay, so 8 power 1 by 3 is like a power minus n, we have to take the nth root. So here what will happen? So this will become cube root of 8. I hope you can understand everything very clearly. Fine. Okay, so now this will become 1 into, what about this 1 by 4 power 1? It's going to be simply 1 by 4 only, plus, what about cube root of 8? It's not much complicated, it's easy only. Cube root of 8 is going to be 2. You can easily tell that, right? Because 2 into 2 into 2 will only give you 8. So in that case, cube root of 8 will be equal to simply 2 only. Okay, alright. So now this will be equal to 1 into 1 by 4 is again 1 by 4 plus 2. So this is going to be the answer. So when I try to write it as a mixed fraction, I can just put them together. That's it. This whole number 2, then followed by the other fraction. Okay, 1 by 4. So 1 by 4 is going to be the answer for this question. And if at all we want the answer in terms of an improper fraction, what we can do here is we can just convert it to an improper fraction. So how can that be done? So 4 2s are 8. 8 plus 1, 9. So 9 by 4. This is going to be the answer. Same answer, but we are expressing in terms of an improper fraction. So mixed fraction or improper fraction, anything is okay. So based on how we have the answer. So these are going to be the answers. Okay, so this is going to be the answer for this question. I hope this second question is also very clear to you, both these subdivisions, the way how we solved. Yeah, we'll move on to the next question. To question number 3. So here again we have got two subdivisions, so we'll work them one by one. Again we have to simplify these given expressions. So our first subdivision here is 8 by 125 raised to the power minus 1 by 3. So again a very simple question only, because we have seen the previous two questions, right? It's going to be comparatively very easier. So what we are going to do here is, as usual, so we have a fraction which is raised to a negative power. So first of all what we have to do is we have to do a reciprocal process. Okay, so that's the first thing we have to do here. So 8 by 125 will now become 125 divided by 8. The whole raised to the power, what will happen? So it will simply become 1 by 3 now. Okay, yes. So be careful with the power. Power you don't have to reciprocal. You should not do that. Power we have to simply change the sign alone. Okay, yes. So this negative power will just become a positive power. That's it. Okay, it will become the negative of what there was originally. That's what, simple. So 125 by 8 whole power 1 by 3. And as usual we have got 1 by 3. So this 1 by 3 will simply mean cube root of 125 divided by 8. Simple. So now we are supposed to find cube root of this 125 as well as 8. So what is cube root of 125? It's going to be like 5, right? So 5. 5 divided by, what is cube root of 8 will be? Cube root of 8 will be it's going to be like 2. So you are finally getting 5 by 2 to be your answer. And if we need to express the same answer in terms of a mixed fraction, what we can do here is like we can just turn, or we can just divide this 5 by 2, right? Okay, so 5 by 2, it's exactly 2 times, right? So that means the 2 is going to be the whole number part, and what would be the remaining? 2 2s are 4, the balance will be 1. So you will write it to be 1 by 2. I hope you can understand this. This is going to be a very basic thing only, right? So let me repeat it. 5 by 2 it is there. So 5 I am dividing by 2. So it's like 2 times, right? 2 2s are 4, we can go up to 4. So 2 times, so 2 I am writing in the front, and the remainder 1 by 2 I am writing here as a proper fraction which comes along with the whole number. So this is going to be the answer in terms of a mixed fraction. Okay, yes, fine. Yeah, now moving on to the second subdivision of the same question. So here we have got 0.027 raised to the power minus 1 by 3. So this is what we have here. So now this will be equal to 0.027. Okay, fine. Yes, now the 0.027 we have in a decimal form, is it or not? So now what we have to do here is we will try rewriting this decimal expression as a fraction. Okay, yes. So then it will become much comfortable for us to solve the problem. That's why. So we'll try to express this decimal form in terms of a fraction. So for which what I'm going to do here is 0.027. Okay, yes. So I've got this 27, right? I'm writing the 27, and now I'm going to write 27 divided by, just see how many places are there for decimal. So there are 3 decimal places before which we have the point, the decimal point. So that means correspondingly I can do what? I can divide this 27 by 1000. I can divide, is it or not? I can divide by 1000. So that 27 by 1000 will what be equal to this 0.027. Yes, all right. So now raised to the power minus 1 by 3 I can do now. Fine, all right, okay. So I hope you can understand what I am doing here. This decimal I am just turning it to be a fraction. So I can just rewrite this as 27 divided by 1000. Why especially I should divide by 1000? Because there are 3 places. That's why I am dividing by 1000. Now hereafter the process is going to be very easy, very easy. So now this will be equal to 27 by 1000 whole power minus 1 by 3. This is what we have, right? So as usual, we will just take the reciprocal of the expression. So we will have 1000 divided by 27. Okay, all right. So this will become 1000 divided by 27 to the whole power. Now it is no more minus 1 by 3. Now it will become just 1 by 3. Okay, be careful in that, in using those axioms. So when we do the reciprocal, the power will become the negative. Okay, I mean that originally what you have, that opposite sign it will become. That's what I'm telling repeatedly, negative. Okay, so it was negative there, and now it will turn positive. So that's what. So 1000 by 27 whole power 1 by 3. So now this will become as usual cube root of. So this is cube root of 1000 divided by 27, and I hope it is easy for you to decide what is cube root of 1000. Okay, so since we are getting zeros, you can easily tell 10 is going to be the answer, right? Because 10 into 10 into 10 cube, if you perform only, you will be getting 1000. So that means this cube root of 1000 will be 10 divided by this cube root of 27 is what? It's simple, 3. It's not a very big number, right? 3. So it's going to be 3. So 10 by 3 is going to be the answer. And as usual, here how we wrote here, the same way here also we'll try to express this 10 by 3 as a mixer fraction. So what we will get here, so we will have 10 by 3 now, it will go up to 3 3s are 9, right? So we can go up to 3 3s are 9. So the integer part, the whole number part will be, it will be 3. So 3, what about the balance, the remainder? Remainder will be 1, right? Because 3 3s are 9 we got. So that means 10 and 9. The remainder will be 1. So 1 you put here divided by 3. So 3 1 by 3 is going to be the same answer expressed in terms of a mixed fraction, and that's going to be the answer for our this second subdivision question. And yes, successfully I completed the third question also, both the subdivisions. Move on to the next question. Next is question number 4 with us. Here again we have got 2 subdivisions to simplify. So let's go for the first subdivision of this fourth question. So here we have the question 8 power minus 4 by 3 divided by 2 to the power minus 2, the whole, the entire thing raised to power 1 by 2. So this is what we have. So we have too many expressions. Let's try to work out this very carefully. Okay, yes. So let's deal the exponents individually. Okay, separately we will have to deal. Then we have to later simplify everything. Okay, all right. So yeah, the first step what I'm going to do here is, first of all, I'm just going to take this 8 power minus 4 by 3. Okay, remember this is 8 to the power minus 4 by 3. So what we can do is, since we have a negative power here, I'm going to take the reciprocal of this base, I mean this 8 here. So what will happen? If you take the reciprocal of 8, it is simply 1 by 8, is it or not? So it will be 1 by 8 the whole power. What it will become? Now the power will simply become 4 by 3. I hope you can understand this. Okay, so power will exactly change its sign. So that means it will become 1 by 8 whole power 4 by 3. Now divided by, so come here, here we have what? Here we have 2 to the power minus 2. Okay, again I'm going to do the same thing. So this will become 1 by 2 the whole power simply 2. I hope you can get this also. So I'm just taking the reciprocal of this 2, what I have inside. So this base, so this 2 will become 1 by 2, and for that reason, since I take the reciprocal, I am taking the reciprocal, the power will exactly change its sign. So that means it will become whole power 2. Simple. Okay, now this entire thing is what is raised to the power 1 by 2. So this is also there, that we should not forget. Okay, so I hope this setup is clear to you. Okay, let's continue now. So what we will get here is like, now we have 4 by 3. Okay, the power is 1 by 8, power 4 by 3. This is what we have here. So now what we can do here is, I am just taking this by 3, this power by 3 inside, and that will come as what? That will come as cube root. Okay, alright. So this will become cube root of 1 by 8. Cube root of 1 by 8. Power 4, alright, okay, yes. Now only this 4 alone stays inside, okay. So divided by, what about this 1 by 2 the whole square? So 1 by 2 the whole square is simply like 1 square by 2 square, and that's easy for us to say. This is going to be 1 by 4, is it or not? Yes, 1 by 4. Now the whole to the power, so this is going to be 1 by 2. So we will deal this power 1 by 2 later, okay, yes. First we will just come solve all these things which is what we have inside, then we will come to that last 1 by 2, power 1 by 2, okay. Yeah, continue this. So we will have what? So we have here like, I think we can do this step very carefully here itself, like we will have a cube root of 1 by cube root of 8. This is what we have, right? Because we have cube root of 1 by 8 we have. So that means what will happen to this one is, carefully understand this. This will become cube root of 1 by cube root of 8. Okay. For comfortability, what I will do here is, I will just try to write this expression separately. Okay. Yes. Cube root of 1 by cube root of 8. So that will become cube root of 1 is nothing but 1 divided by cube root of this 8 is going to be 2, right? So 2. Okay. All right. What we have is, we will have 1 by 2 raised to the power 4. This is what we have here. Okay, so it's going to be a very simple expression. The numbers are not going to be very big numbers, no, not much of complication. So cube root of 1 by 8 has become 1 by 2. Now 1 by 2 is what is raised to power 1 by 4. This also you can easily tell. What is 1 by 2 raised to the whole power 4? 1 by 2 power 4 will be what? 1 by 16. It is correct. So 1 by 16, it will simply become 1 by 16. So this entire thing I'm just simplifying and placing here in one step. Okay, for that I'm just taking this as an helping step. Okay, that's why I've written this one separately outside. So 1 by 2 we got inside, 1 by 2 raised to the power 4 we got to be 1 by 16, because 1 power 4 is 1 only. 2 power 4 is what is that? 16. Okay, that's what I've written here. And here we are having divided by 1 by 4. So okay, so we got 1 by 16 divided by 1 by 4. And here also I'm going to do a small kind of alteration. What I'm going to do here is, I'm going to turn this division as multiplication. This is also a very basic rule only, right? So we have a fraction. When we have a division of a fraction, what we can do? When something is divided by a fraction, what we can do here is, like, we can change the division as a multiplication, and for that reason what will become? So this division, this fraction expression will become just reciprocal. That is, this will become 4 by 1. That's simple, right? Okay. So 4 by 1 whole power 1 by 2 we got. So now what we have inside is, like, we have, so this 4 and 16 we can cut it. So this is exactly 1 time, this is exactly 4 times. So we got 1 by 4 inside. So we have 1 by 4, which is what we have inside. So 1 by 4 whole to the power 1 by 2, and I can simplify this step, like, now coming here to 1 by 2. Okay, power 1 by 2 we have. So power 1 by 2 means, what we can do here is, we can take a square root of. Okay, so whenever we take that square root, by default it is understood that this is square root. We don't write a 2 here. Okay, so we need not write that. Okay, that is not needed at all. So I'm just erasing that. So by default it is understood, right? So root of 1 by 4 means it is square root of 1 by 4 only. Okay, 1 by 4. So like for the other roots only, like cube root, fourth root only, we have to mention that number in front. Okay, so right, like if you put a cube root, we'll write a 3 here. If you write a fourth root, you will write a 4 here. So the same way, here we have square root, right? So we don't have to write the 2 here. By default, it is understood that it is a square root. Okay, so square root of 1 by 4 is what we have here, and this is finally, this will be equal to, what is this equal to? Square root of 1 by 4 is very simple. It's like 1, we have 1 divided by, what is root 4? What is square root of 4? Square root of 4 is 2, right? It's easy for us to say it is 2, because 2 square is what is 4. So square root of 4 is 2. So 1 by 2. So finally, our answer for this first subdivision is going to be 1 by 2 is the answer. Now coming here to the second subdivision. So here again we have another question. So let's carefully deal with this question also. So here we have 27 divided by 8 raised to the power 2 by 3 minus 1 by 4 raised to power minus 2 plus 5 power 0. This is what we have. So carefully we'll deal with this. We have got 3 terms here. Okay. So we'll deal them one by one. So coming here, the first term, 27 by 8, the whole power 2 by 3 we have. So as usual, what we can do, this divided by 3 alone, I am going to take it as a cube root. Okay, yes. So cube root of this 27 by 8 will come first. Power raised to the power 2 you will have. Yes, I hope you can understand this, what I am doing here. So this 27 by 8, I am taking it to be power 2 by 3. So I am just taking this 3 alone here. Okay, here we don't have to reciprocal it. Why we need not do that? Because the power what you see is what we see here is already a positive value only. So we don't have any minus 2 by 3 and all, right? So here it is just 2 by 3, positive 2 by 3 only, right? So in that case, we don't have to disturb it. We will take it as it is. And now what we are doing here is like we are just doing this 3 alone, just by 3 alone, just bringing here as a cube root. So cube root of 27 by 8, the whole square we are having. This square is nothing but this numerator 2 is what you see here. So minus, continue here. What about the second expression here? The second term here, what we see is like a 1 by 4 whole power minus 2. So this is what we have here. So now here we got a negative power. So that means here what we can do, here we can very well just take the reciprocal. Yes, you agree with that? Yes, because we have 1 by 4 power minus 2. That 1 by 4 I am going to take a reciprocal. So what happens to 1 by 4? It will simply become 4. That's it. Because reciprocal of 1 by 4 is 4 only. Like reciprocal of 4 is 1 by 4. So reciprocal of 1 by 4 will be the back 4 only. Okay. So 4 raised to the power. What will happen to the power now? So the power will simply become 2. That's it. Okay. Because we had minus 2 there. So when we did the reciprocal process, the power will simply change its sign. So it will become 2 plus 5 power 0. I think 5 power 0 we can easily tell. Anything raised to a power 0 is going to be 1 only. So 5 power 0 is obviously 1 only. So yeah, continue here. So what we will have here is like we will have a cube root of 27 by 8. What is cube root of 27 by 8? Cube root of 27 is 3, right? It's going to be 3 divided by cube root of 8 is going to be 2. So divide by 2, the whole power 2, the whole square. It is like whole square minus. So what about this 4 square? So 4 square is 4 4s are 16 plus this one. So we are getting like this. So now what we can do here is like we have 3 by 2 the whole square. Is it or not? So 3 by 2 the whole square is nothing but 3 square by 2 square. We can rewrite like that, right? So 3 square by 2 square. What is 3 square? 3 square is 9 divided by 2 square is 4. And we have minus 16 plus 1. We have followed by 2 integers, right? Okay. So we have a minus 16 plus 1. We can operate these two numbers, right? Minus 16 plus 1 will become minus 15. It will simply become minus 15. So we are finally having 9 by 4 minus 15. This is what we have. So now we have to do this simplification also. So we have to do a minus, I mean like 9 by 4 we have to do a minus with 15 we have to do, right? Okay. So in that case what we can do is we'll better take the LCM. So LCM means we'll take the common denominator to be 4. So what happens is like this will become 9 only. This will be remaining as 9 itself. And this minus 15 is there. 15 4s are will become 60. So yes. So 9 minus 60 divided by 4 we will be getting. So now continuing that we will be getting 9 minus 60 to be equal to minus 51 divided by 4. So minus 51 divided by 4 is going to be the answer. But yet we will be able to turn this as a mixed fraction. It is possible, right? So we have this minus. Don't disturb it. Place that minus as it is. So 51 by 4. What about 51 by 4? So 51 by 4, if you want to write as a mixed fraction, what we can do here is like try dividing this 51 by 4. So in 4 tables, how much time this 51 will come? So you can go up to like 4 10s are 40, 4 11s are 44, 4 12s are 48 we can go, right? 4 12s are 48, but 4 13s are will become 52, right? So in that case, we can go up to 4 12s are 48. Alright, okay, 4 12s are 48 we can go, and we'll be still remaining with 3, right? Okay, so the 3 comes here, divide by 4. So this will simply become minus 12 3 by 4. This is going to be the mixed fraction expression for this given value. So minus 51 by 5, I'm rewriting it as a mixed fraction. So this will become like this, and this is going to be the answer for our second subdivision of this fourth question. I hope both these questions are also very clear to you. Yes, we move on to the next question. Going for question number 5, again we have to simplify two subdivisions, so let's do them one by one. Our first question here is 3 power 2 the whole power 0 plus 3 power minus 4 into 3 power 6 plus 1 by 3 power minus 2. So this is what we have. So it's not going to be a very complicated question, a very easy question only. So again we are supposed to use the axioms and simplify this question very carefully. Okay, so it is all based on how thorough we are with these basic axioms, these basic laws. Okay, all right. Yeah, coming back here. So we have 3 power 2 the whole power 0. So this is like a power m the whole power n. So we have got power of power. Yes. So that means what we can do here is we can just simply multiply the powers. Is it or not? So a power m the whole power n. That means like this is like the third law here. A power m the whole power n. What we can do is when you have power of power, we can just multiply the powers. So that means here we can do 2 into 0. So that will give you simply 0 only. Is it or not? Yes. Okay. So plus we have here this plus, after that followed by we have here 3 power minus 4 into 3 power 6. So this is matching with our first law, first axiom. So we have a power m into a power n. So when we have two exponents with same basis getting multiplied, what happens to the powers? The powers get added up. Okay, so it's equal to a power m plus n. So that means here 3 power minus 4 into 3 power 6 will simply become 3 to the power minus 4 plus 6. I'm just adding up the powers, that's it. Okay, because we have multiplication in between, so the powers will get added up. So minus 4 plus 6 it will become. So yes, plus, yeah, following we have got 1 by 3 to the whole power minus 2. Okay, yes, this we are much familiar of. So like 1 by 3 the whole power minus 2 will become, so I can just take the reciprocal of that expression what I have inside. So 1 by 3, if you take the reciprocal of 1 by 3, it will simply become 3 only. So now what will happen is 3 to the power. What about the power? What happens to the power now? When we just multiply, I mean like when you just reciprocal the power, the base what we have inside, the power will simply become, it will change the sign. So this 1 by 3 became 3, so that this will become simply 2. That's it. Okay, so 3 power 2 it will become. So now hereafter it is going to be very easy only. So we have 3 power 0. 3 power 0 we know very well, it's going to be 1 only. So plus we have what we have next? We have 3 power. Okay, 3 power. What about minus 4 plus 6? It's going to be 2 only. Plus here again we have 3 square. So I think we can do it in one stitch. So 1 plus this is 9 plus this is 9. So finally the answer will become 19 for this question. Okay, yes, now it appears to be very simple, right? Okay, only thing is we should carefully apply the axioms, and once after we are getting a very delicate steps thereafter we can easily follow and then get the answer. Okay, so 3 square is 9, 3 square is 9, so 1 plus 9 plus 9 will become 19. Okay, yes, yeah, this is going to be the answer for our first subdivision here. Coming here to the second question, so second subdivision, here we have 9 to the power 5 by 2 minus 3 into 5 power 0 minus 1 by 81 power minus 1 by 2. So this is all we have here. So again we have to do the same kind of things here. So what is the first step I'm going to do here is I'm going to take this expression now, that is 9 raised to the power 5 by 2. From here we are going to start. So as usual what we can do here is, like here we don't have to do any kind of reciprocal or anything, that is nothing needed here. Why? Because here we have the power itself to be positive only. So in that case I don't have to do reciprocal process and all. What I'm going to do is I'm going to consider this by 2 first. So I have 9 raised to the power 5 by 2. Is it or not? That by 2 alone I am going to take here, and that will come as what? That will come as square root, right? Okay, so square root of 9. Now whole raised to the power, now it will be simply only 5. Okay, why? Because that by 2 only came inside a square root, that you have to properly understand. Okay, yeah, follow it by minus 3 into, what about 5 power 0? 5 power 0 is, it's going to be 1. Anything power 0 is going to be 1 minus, now again coming here we have 1 by 81 power minus 1 by 2. So here the power is negative. So here what we can do here is like we can do the reciprocal process, right? Okay, ready? So 1 by 81, I'm going to take the reciprocal of 1 by 81, which is simply 81. Yes, is it or not? So it's going to be 81. So 81 power, what about power? Power will now become just 1 by 2. You have to understand that very clearly, because we had 1 by 81. That 1 by 81 only I turned it as 81. I take the reciprocal. I am taking the reciprocal. So what will become to the power? Power will change the sign. So it will become 1 by 2. Okay, yes, continue. So what we have here is like root 9 power 5. Okay, what is root 9? What is square root of 9? Square root of 9 is 3. Okay, so 3 power 5 minus 3 into 1 will be simply 3 only, minus, what about this 81 power half? What is 81 power half? That power half will be again coming here in the front as what? It will become root of 81. Simple, right? Yes. So I hope you can understand this also. Like what we have done here, the same thing I have done here. But here we had power half, here we had 9, root 9 here. Here we have root 81 because we have inside 81 inside, right? So 81 power half will become square root of 81. Very simple. Okay, yes. So yeah, continue. So now here we have 3 power 5 we have. What is 3 power 5? So 3 power 5 is what? Already we know 3 power 4 is 81, right? Okay, because in previous problems we had that 3 power 4 is 81. So 3 power 5 means one more 3 we have to multiply. That's it, very simple. So just try doing 81 into 3. What is 81 into 3? 81 3s are like 243, is it or not? So that means 3 power 5 is 243 minus 3 and minus, what about this expression? Root 81, square root of 81, we know that, right? Because 9 square is what is 81. So that means root 81 will be simply 9. It's going to be 9. Okay. So that means now what I will have here is 243 minus, I will just clamp them together. I'll write as minus 12. I can do that, right? Very well, I can do that, right? 243 minus 12, because this is minus 3 minus 9. I am writing as one stroke minus 12. Okay. Now I can just simply simplify now, just subtraction, right? Okay. So I will have 1, I will have 3, I will have 2. So 231 is going to be the answer for this question. I hope you are able to understand these two subdivisions of this question number 5 also. Yes, let's move on to the next question. Next is question number 6 with us. Here again we have to simplify two subdivisions. First subdivision here is 16 power 3 by 4 plus 2 into 1 by 2 to the power minus 1 into 3 power 0. Okay, yes. So this is the first question. So let's carefully simplify this. So first we have 16 power 3 by 4. So this is all we have. So as usual we have a fraction here. So I'm going to consider this by 4 alone now first. So what I'm going to do here is like this by 4 I'm going to bring here to the front as 4th root of 16 raised to the power 3. I hope you can get this easily. So I'm just using the a power 1 by n property only. So this by 4, this fraction in the power, what is this? This is 16 power 1 by 4 is going to come in the front as 4th root of 16 power. Now in the power you will simply have only the 3. Okay, yes, plus 2. Okay, this 2 is there, this 2. And what about this 1 by 2 to the power minus 1? 1 by 2 power minus 1 will become 1 by 2 is it is there. I'm going to turn this 1 by 2 as the reciprocal. So it will simply become 2, and 2 power it will be no more minus 1. The power will become 1. Why? Because you are doing the reciprocal, the power will become, it's negative. I mean it will change the sign. So that's why. So into, so what about 3 power 0? 3 power 0, no doubt it's going to be 1 only. Yes, fine. Okay, yeah, continue. So what we now have here is, I think we can simply deal with this question, right? This 4th root of 16 we have. What is 4th root of 16? So 4th root of 16 will be nothing but the number which when multiplied with itself for 4 times will give you this 16. So what number it will be? So 1 power 4 will be 4. So 2 power 4 we can try. So 2 into 2 into 2 into 2 will be 16, right? Actually, in one of the previous questions also, like we had this same calculation. So 4th root of 16 is going to be 2 only. So it's going to be 2 power 3 plus 2 into this 2 power 1 is going to be 2 only. So into 1, we did not deal that. So this is equal to 2 power 3. What is 2 power 3? 2 power 3 is 2 into 2 into 2, which will be 8. So 8 plus we have 2 2s are, which is 4. And now it's simple. 8 plus 4 will be 12 is the answer for our first subdivision. Okay, yes, it's going to be very simple. Just we have to just simplify the first step, and there onwards everything will be following very easily. So answer is 12 for this first subdivision. So come to the second subdivision. So this question size is very huge, it seems, right? Okay, but anyways we'll try this. So this is equal to, what we have here is like we have 81 power 3 by 4 minus 1 by 32 power minus 2 by 5 plus, here we have 3 terms multiplied here, right? 8 power 1 by 3, 1 by 2 power minus 1, 2 power 0, everything is there, No matter, once you are thorough with all the things, once you are very sure with what we are about to do, you can be very clear, you can be very confident in solving the problem. So yeah, coming here, 81 power 3 by 4. So as usual, this by 4 I am going to take in the front as 4th root of 81. So listen carefully, 4th root of 81 power 3. Yes, okay, minus what we have next is 1 by 32 to the power minus 2 by 5 we have. So this 1 by 32 I am going to rewrite this as simply 32. Now it will, what will happen to the power? Power will just change its sign. So 1 by 32 is what I am rewriting as 32. The power, what it is already negative, it will now become positive. So it will simply become 2 by 5. I hope you can understand this. So 1 by 32 I am just changing it to be the reciprocal term. Reciprocal means the power will change its sign. So minus 2 by 5 has become 2 by 5, simply 2 by 5. Okay, yes, continue. Now it is like plus. What about this 8 power 1 by 3? 8 power 1 by 3 can be rewritten as cube root. I can bring this as cube root of 8, right? Cube root of 8. And what about this 1 by 2 to the power minus 1? That can be rewritten as, what is this this value? So 1 by 2 power minus 1 can be written as simply 2 power 1. It will become like 1, right? Because I am just taking the reciprocal and changing the sign of the power. Okay, that's what I am doing. And last one we have 2 power 0. The 2 power 0 is no doubt that's going to be 1. Okay, yes, now I think it will be very easy for us to solve the problem. Yeah, here we have got like 4th root of 81. What is 4th root of 81? It's going to be 3, right? Because we have seen in the first few questions itself the same calculation. 4th root of 81 is going to be 3. So 3 power 3 minus, what do we have here? We have 32 raised to the power 2 by 5 we have. So this one, 32 power 2 by 5, I am going to bring this divided by 5 to the front side, so that it will become what? It will come in the front as 5th root of 32. Understand it carefully. It will become 5th root of 32, because like we had by 3, that by 3 is coming as cube root. If we have by 4 in the power, that is coming as 4th root. Now we got by 5 here, that by 5 will come as 5th root only. Is it or not? So 5th root of this 32 whole power. Now we have power as 2 only. Now next is plus. Now we will individually see all these values. This cube root of 8 is there, that is going to be 8. Cube root of 8 is going to be 2, that is 2 into 2 power 1 is going to be 2. That's it. Okay, right? This one we need not, because anyways we multiply it, that will go off. So this is equal to, now what will happen here is 3 power 3 will be 27 minus, what about this 5th root of 32? 5th root of 32 is going to be like which number you multiply with itself for 5 times, you get 32. Okay, yes. So you start from the very basic number. 1 power, it's always going to be 1 only. Just try for 2. Try doing for 2. 2 power 5 is what? Can you try to calculate? 2 power 5 is like 2 into 2 into 2 into 2 into 2. 5 times. Is it or not? First 3 2's will give you 8. Next 2 2's will give you 4. So 8 4's are 32. You got it. That's it. So that means 5th root of 32 is going to be 2. And again we have a square for this, plus what about this 2 2's are, this will be a 4. Alright, yes. So now finally we have 27 minus, what about this 2 square? This 2 square is 4 plus 4. And now it's very easy. I can just cut this plus 4 and minus 4. We'll be simply ending up with the answer as 27. So 27 is going to be the answer for our second subdivision of this question. Okay, I hope this 6th question, both these subdivisions are again clear to you. Yeah, we'll move on to the next question now. Next is question number 7 with us. Again a simplification question. We have 2 subdivisions here. So first subdivision we have root of 2 square into 4th root of 256 divided by cube root of 64 minus 1 by 2 power minus 2. So this is all we have here. So we'll try to simplify this very carefully. So yes, we'll try to do it even faster. I mean, like we'll just try to do few steps in our mind itself. Okay, yes. Why? Because like we can't do all the steps in an elaborated way. That's the reason. So for instance, we just take this one. Okay, root of 2 square is there. So what is root of 2 square? It's simply root of 4, right? Okay, so root 4 we can easily tell it is going to be 2 only. Fine, yes. So 2. Or otherwise what we can tell is like this root and square are, they are going to be like exactly complement operations, right? Okay, so root of some number square, you will end up with the same number only basically, right? Okay, so root of 2 square is root 4 and 2. Yes, fine. Okay, this is done. Multiplied by, what about this 4th root of 256? So now we have to think for 4th root of 256, which number will come, that is which number, which one multiplied with itself for 4 times, you will get this 256. and that number is going to be the answer for 4th root of 256. Okay, yes. So which number we can just think of, like we can even try from the least number, like 1 it is going to be useless, like 2 we can do, 2 power 4 will be 16, 3 power 4 will be 81, we saw that, and we saw up to like what number we can just go for the next number also, like 3 power 4 we got 81, 4 power 4, can you try doing 4 power 4? So 4 power 4 will be nothing but 4 into 4 into 4 into 4. That means 16 into 16. What is 16 into 16? It's going to be nothing but 256 only. So that means no doubt 4th root of 256 is simply 4 only. I hope you are able to get this. Why? Because 4 if you multiplied with itself for 4 times only, you will end up with getting 256. So that's why 4th root of 256 is 4. Okay, done. Divided by denominator we have here to be cube root of 64. This also we can easily tell, right? Cube root of 64 is nothing but it's going to be 4 only, because we have used it in our previous questions also. We came across this same calculation. So cube root of 64 is 4. Why? Because like 4 into 4 into 4 3 times. So we'll only give you 64. So that means this will be 4 minus, we have another part here. So here we have 1 by 2 raised to the power minus 2. So this can be turned as 2 power simply power 2 only. I hope you got this, because I am taking the reciprocal and changing the power, changing the sign of the power. Okay, yes. So 2 power 2 it became. So now it is very simply like I can cut this 4 and 4. So I will be getting 2 here. 2 minus this 2 square will become 4. So 2 minus 4 is simply minus 2, and that's going to be the answer for our first subdivision of this question. So minus 2 is the answer. Now come here, second question we have. A little lengthy expression we have. So first we'll have a we'll just take a moment for us to observe the question. So we have a huge fraction here. Basically we have a numerator term. We have the numerator to be 3 power minus 6 by 7 into 4 power, note it carefully, 4 power minus 3 by 7 into 9 power, again note it carefully, 9 power 3 by 7 into 2 power 6 by 7. Okay, so like all these previous questions, the moment we see a negative power, we try to do what? We always try to do it by what? We just turn it reciprocal, and then we have to change the sign. That is how we did here. But hold on for a moment. For this question, we will just see it even more carefully. Okay, we will take a close observation here. So 3 power we have minus 6 by 7, and next see here this 4 is here, and next see here we have 9 power something. Okay, we have got 3 power something and 9 power something, and again we have 2 power something. Okay, this is how we have. Okay, forget about the powers as of now. So why I am particularly spotting out this 4 and 9 is, this 4 is nothing but this 2 square. Is it or not? This 4 is nothing but 2 square, and 9 is nothing but this 3 square. So that is the point we should carefully have a look at it. So okay, yes. So we'll try to do it in that way now. What happens is, I'm going to not change these values. Okay, this 3 power I'm going to leave it as it is. Same way 2 power also I'm going to leave it as it is. Okay, now look at what I'm going to do now. So first I'm going to take the numerator terms. Okay, so here I have 3 power minus 6 by 7 as it is, no disturbance, into, what about this 4? This 4 only I'm going to rewrite now as 2 square power minus 3 by 7. I hope you got this. Okay, I am going to rewrite this 4 power 3 by minus 3 by 7 as 2 square power minus 3 by 7. Very simple, that's it. Okay, similarly multiplied by, similarly this 9 also I am going to rewrite as 3 square power 3 by 7. Yes, fine, you can observe it, right? Why? Because this 4 is 2 square, this 3 is 3 square. That's why I am replacing that 4 and 9 by respectively 2 square and 3 square. Okay, yes. Multiplied by, we have got a 2 power 6 by 7. That also I am just going to place as it is, no disturbance. So everything is done. So this is what we have in the numerator. Now come to the denominator part. Denominator, what are all the things we have? We have 2 square plus 2 power 0 plus 2 power minus 2. This is what we have, right? So we'll try to simplify this also here itself. Okay, yes. First of all, 2 square you can easily tell it's going to be 4 plus 2 power 0 also we know it is 1 plus. Now come here, we have 2 power minus 2. What about this 2 power minus 2? 2 power minus 2, we'll try to do it mentally. Okay, 2 power minus 2 is nothing but we can turn this 2 as 1 by 2. Okay, whatever I am telling now orally, you try to imagine, or you can even write it in a step. Separately, you just write as a step. Okay, just to give a practice, I am giving this to you. So this 2 power minus 2 I am going to rewrite as 2. I am going to change this 2. I am going to change it like 1 by 2. So for that, what happens to the power? The power will change its sign. So this expression will now become 1 by 2 power 2. I hope you got it, no doubt. So if you want, you can even write it separately. So 1 by 2 power 2 it will become. Now what is 1 by 2 power 2? 1 by 2 the whole square it is. So it will simply be 1 by 4. Fine, okay. So in order to save the steps is what I am trying to do, all these steps, okay, in a compact way. Okay, all right. Anyways, I hope you are able to get this, you are able to understand this. Okay, so you can even, if you feel it little confused or complicated, you try doing this calculation separately. You will get 2 power minus 2, it's equal to 1 by 2 power 2. So that means it's going to be 1 by 4. So if you have carefully listened to all these previous problems, if you have followed it, this calculation won't appear to be much difficult for you. It can easily deal with that. Okay, so we are getting like this expression in the denominator. Once again, come back to the numerator. So what we have in the numerator? So now is what we have to play the game very carefully. Okay, so we have 3 power minus 6 by 7. Okay, this 3 power minus 6 by 7, let us have it as it is. Now come directly to this term. Come here. So here we have 3 square power 3 by 7. Okay, why I am taking this is, this expression is now looking like a power m the whole power n. I can compare this one with this one, right? So because we have power of power. Okay, so we have 3 square power 3 by 7. So 3 power 2 whole power 3 by 7, that can be rewritten as 3 power. Okay, 3 power. I can do what? I can multiply these two powers. That is this 2 into 3 by 7 I can do. That's what I am coming to say. So 2 into 3 by 7, you try to do it, you will be getting 6 by 7. Fine, okay. Now I can, I hope you can take it whatever I am coming to say. Okay, so this 3 power minus 6 by 7, along with that, next to it, okay, the next to it itself I am just taking this 3 square power 2 by 7. Okay, what is 3 square now? 3 power 2 the whole power 3 by 7. I am just multiplying the powers. That's what is giving me 3 to the power 6 by 7. Now follow it. Okay, follow it into, come here, we have 2 square power minus 3 by 7. Here also we have the same way, power of power. So what happens? So you can rewrite it as 2 to the power. What happens to this one? This will become 2 into minus 3 by 7, which will be minus 6 by 7 into last one we have 2 to the power 6 by 7. This is all we have. So I hope now you are able to catch what I am going to do now. My aim is, my objective is like trying to bring similar bases. Okay, similar bases together. Okay, that's what I'm trying to do here. Okay, yes, fine. Okay, now come to the denominator portion. Here we have what? We have 4 plus 1 plus 1 by 4. So that means like this is like 5 1 by 4, right? So I can rewrite as 5 1 by 4. So I can write as 5 1 by 4. I can rewrite like this. Now again come back to the numerator. So numerator, what we have here is like we have 3 power minus 6 by 7 into 3 power 6 by 7, and here we have 2 power minus 6 by 7 into 2 power 6 by 7. So that means I can bring these two together, because these two have got same base, these two have got, these two have same power, these two have same power. This have got same base, I'm sorry, they have the same base but different powers are there. I can just multiply it with the first property, a power m into a power n. I can do that, right? So I can try to do it like 3 power. What about this one? It will become minus 6 by 7 plus 6 by 7 multiplied with, here also I can do the same thing, 2 power minus 6 by 7 into plus 6 by 7. I can add it, right? Why? Because we have the same bases, we can multiply. When we multiply, the powers will get added, plus 6 by 7. I can do this. So now divided by, what about this 5 1 by 4? I can change it as an improper fraction. If I try to do it, I will be getting 4 5s are 20, 20 plus 1 is 21. So I will get 21 by 4. So finally what I will get here is, I will be getting this to be equal to, so I think I can continue this, we will be able to view this also. So what I will have here is 3 to the power, I will have 3 to the power, this will become what? This will become simply 0 into 2 to the power, also it is 0. Okay, why? Because this is minus 6 by 7 plus 6 by 7. Here also the same. So the powers will get cancelled. They will become 0 and 0. Divide by 21 by 4. This is all we have. And what do you think about the numerator now? Numerator is nothing but 1 ones are 1 only. So we simply have 1 divided by 21 by 4, and that's nothing but 4 by 21, and that's going to be your final answer for this question. Okay, so we have equipped slightly a different technique here, that's it. Okay, so I'm not just deviating out from these axioms. I'm using the same axioms only to solve the problem, but this time what we are trying to do here is like we are just taking the similar bases together so that it will be easy for us to apply this axiom and get the answer. So this is what I'm trying to do here. So anyways, we got the answer to be 4 by 21 for this question, and that's answer for these two questions. So first one minus 2 and second one 4 by 21. These are going to be answers for our question number 7. Now we'll move to this next question. Next is question number 8 with us. Again with two subdivisions, we have to simplify these expressions. So yeah, question number 1, first subdivision here we have 32 to the power 2 by 5 into 4 to the power 1 by 2 minus 1 by 2 into 8 to the power 1 by 3 whole divided by 2 power minus 2 divided by 64 power minus 1 by 3. So again, we'll not complicate much. We'll try to do the questions by shortening the steps. Okay, yes, fine. Yeah, okay, yes. So first we will start with this 32 to the power 2 by 5. Okay, I'm going to rewrite this as this by 5. It will come to the front as 5th root. Okay, all right. So 5th root of 32 power 2. Okay, I hope this you can understand this. So as usual, we have came across the same kind of calculation in the previous questions. So multiplied with this also we'll try to do it in a technical way. Carefully we just observe this. 4 power minus 1 by 2 is there. Okay, yes. So the power is negative. So for that reason, what I'm going to do is I'm going to rewrite this 4 as 1 by 4. Okay, yes. So we have only a small space here. So I hope I don't want to confuse you, but yet I just want to reveal the things, give you the things in a very clear way. Okay, so for that you carefully understand whatever things I am writing, and more than that you try to understand what I am telling also. Okay, yes, only then you can clearly follow in understanding. Is fine. Yeah. So 4, I am going to rewrite this as 1 by 4. So now what will you think it will happen to the power? So this 4 power 1 minus 1 by 2 was there. So I am replacing that 4 by 1 by 4. So what happens to the power? The power will become 1 by 2. And what do you think about that 1 by 2? That 1 by 2 is nothing but simply square root of. Yes, right? Power 1 by 2 is nothing but square root of. Okay, the entire thing I am trying to do in this same step itself. Okay, yes. Multiplied with, what about this 8 power 1 by 3? This will also become cube root of 8. Yeah, okay, yes. So yeah, come on. Is now coming to the denominator part. Denominator, what do you have here? Here we have got 2 to the power minus 2, is it or not? So what happens to the 2 power minus 2? It will become simply what? It will become like 1 by 2 whole square, is it or not? Why? Because this 2 I am going to write it as a reciprocal. It will become 1 by 2, and power I am going to change the sign. It will become simply whole power. It was minus 2 here, and now it will become plus 2. Okay, 1 by 2 power 2. So that means 1 by 2 whole square it will become. Yes, is it or not? So 1 by 2 whole square is nothing but 1 by 4 only. Okay, I'm just doing this all those calculations here itself. Okay, and if you feel that you have any doubts, you separately work these calculations, and then you will also come to get the same values. Okay, so 2 power minus 2, I'm going to replace it as 1 by 4. Okay, directly. Yes, divided by, now divided by, what about the 64 power minus 1 by 3? So the 64 power minus 1 by 3 can be written as 1 by 64. Yes, 1 by 64. It will become what? 1 by 64 power 1 by 3. Is it or not? And remember what we have done in the numerator, the same thing now I am going to do. Okay, so this is like 1 by 64, but power 1 by 3 it is, right? Okay, but power 1 by 3 can be rewritten as what? You can be written as cube root of. All right, okay, I feel you are feeling comfortable. I hope it is comfortable for you. So I'm going to write as 1 by 64 power 1 by 3. That is what I would have written there, but I'm just cutting it short like I'm just taking it to be the front like cube root. Okay, I'm just taking it to be cube root, and then so like this is what I'm just doing here. So this is like is equal to, so now we'll try to simplify the same way. Okay, we'll just minimize the steps here. So like 5th root of 32. Okay, what is 5th root of 32? It is going to be 2 only, right? So you'll get 2 square, which will be 4 multiplied by, what about this expression? This expression will be root of 1 by 4. That's going to be 2 multiplied by, what is cube root of 8? That is going to be 2. Yeah, clear to you? Yes, see them individually. 5th root of 32 is 2. That 2 is what I am squaring. That's what is this 4. And this for 1 by 4 root I am taking 1 by 2, and cube root of 8 is I am taking 2. Okay, this is what I am getting. Now again come back to the denominator place. Denominator we have 1 by 4. Okay, 1 by 4 divided by, what about this one? Divided by, this is also 1 by 4 only, right? Because cube root of 1 by 64 is going to be 1 by 4 only. No doubt in that, right? Because cube root of 1 is 1. Cube root of 64 is 4 only. No doubt in that. So I will be getting 1 by 4 only here. So 1 by 4 already I put, divided by 1 by 4. So what I am going to do now is, I am going to turn this division as multiplication. If I turn this as multiplication, then what will become? what happens here? So it will simply become 4 by 1. Okay, so already in that place 1 by 4 would be coming, that is the correct number that should be coming, but since I am changing this division as multiplication sign, it is becoming 4 by 1. That's it. Okay, and again I am telling, if you have doubts, you separately work it out and see. Okay, yes, yeah, yes. Now continuing it, what we will have here is like we will have like this 2 and this 2, they will get cancelled, and numerator you will have only 4 divided by, what about denominator? I can cut this 4 and 4, so I will be having by 1 only, so that means 4 by 1, I will simply have 4 to be the answer. Okay, yes, so this is what I will be getting for that first subdivision. Yes, this is all we have done here. So for the first thing, to get the answer, so 4 is going to be the answer for our first question, first subdivision of this 8th question. Now coming here for the second subdivision, here we have got another interesting question here. Let's see the question. What is the question here? Is like we have the second subdivision. So 5 to the power 2 multiplied by x plus 6 into 25 power minus 7 plus 2x, entire thing divided by 125 power 2x. So this is all we have here. Yes. Yeah, carefully we'll just try to solve the problem. Here also we'll technically try to do this problem. Okay, yes. So what we will try to do here is like, first we will have this 5 power. Okay, 5 power. What we have here? We have like 2 into x plus 6. Okay, as of now we will have it as it is. Okay, no disturbance. Into, what about this 25? We will try to write this 25 also a power of 5. 25 I tried to write as power of 5. Okay, right? This 25 can be written as what? This can be written as 5 square, right? Okay, 5 square power minus 7 plus 2x. This is what you will get. Correct? Yes. Now divided by, come to the denominator. Denominator we got 125 power 2x. Now again, this 125 also I am going to try to rewrite as a power of 5. So what will happen for 125? 125 will be nothing but 5 cube only, right? Because 5 power 1 is 5, 5 power 2 is 25, and 5 power 3 is 125. So this 125 I am going to replace it as 5 cube power 2x. I hope it is clear to you. Now all these powers are, all these bases are going to be uniform, right? 5 power, 5 power, 5 power. Everything is like now looking like 5 power. Okay, yes. So now I think we can expand it. So once we try to expand it, what you will get? 5 to the power. Now bring this 2 inside. Okay, we can multiply this 2 inside, right? So what will happen? 2 into x. So 2x plus 2 into 6 will be 12 into, what about this term here? So this term will be like 5 power to the whole power minus 7 plus 2x, right? Yes or no? So here also the same thing will happen. What happens to power of power? Power of power means the powers get multiplied, is it or not? Like how we have multiplication. Here also this 2 will be multiplied with this minus 7 plus 2x. So what I'm going to do is I'm going to directly multiply now. So it will give me 2 into minus 7 minus 14 plus 2 into 2x will be 4x. Yes, is it clear to you? Yes, fine. So this is what is happening over here. So I'm just taking like I'm just multiplying this inside. So that is what is giving me this whole divided by. Now come here. Here we have 5 power 3 the whole power 2x. Here also the same thing happens. Power of power we get multiplied it. So it will become 5 power 6x. It will become 5 power 6x. So now I can just simplify it as what? I can just take this as 5 power 2x plus 12 into 5 power minus 14 plus 4x divided by 5 power 6x. This is all I have, right? So now what I'm going to do is, first of all, I will just take this 5 power this value multiplied with 5 power this value. So I have the same basis, but the powers are different. When they get multiplied, the powers will get added up. Is it or not? So it will become 5 power 2x plus 12 minus 14 plus 4x. This is what will happen. The entire thing divided by 5 power 6. Do you understand this? This is what will happen. Okay, all right. Now again, 5 power this expression divided by 5 power 6x. What will happen? Now I can use this second axiom, that is a power m divided by a power n. So when two expressions, they have same basis but different power, they get divided. Now what we can do with the powers? We can subtract the powers. Okay, the numerator's power divided by the denominator's power, we can subtract like that. So once we try to do that, what we will be getting here is like we will be getting it to be is equal to, I think this space is enough for me. So 5 power we will be getting 2x plus 12 minus 14 plus 4x. This 6x will become minus 6x. Is the point clear? Yes. So this will be equal to 5 power 2x plus 12 minus 14 plus 4x minus 6x. This is all I will be getting finally. And now what I can do is I can just cut this 2x, 4x minus 6x, because 2 plus 4x will be equal to 6x. Yes, 2x plus 4x will be equal to 6x. 6x minus 6x will be 0x. Right, my x terms will be vanished. Okay, that will be gone, and I will be only left with plus 12 minus 14. What is plus 12 minus 14? That will be 5 to the power. I will be simply left with 5 to the power. Plus 12 minus 14 means it's like minus 2. So that means 5 power minus 2 is what I am getting. 5 power minus 2, if I try to simplify, I will be getting 1 by 5 the whole square, and that means this will be equal to 1 by 25. Yes, is it or not? Because this 5 power minus 2, I am going to take it reciprocal 1 by 5. The power will become simply 2, because it was minus 2 here. It will become, change its sign, it will become 2 here. So 1 by 5, the whole square is nothing but 1 by 25, and that's going to be the answer for our second subdivision of this question. So I hope you are able to understand these two subdivisions also under question number 8. We'll move on to the next question. Next we are with question number 9. Here again we have a simplification question. We are with two subdivisions. Let's try to work out them one by one. So our first subdivision question here is, like we have x power m by x power n whole raised to the power l multiplied with x power n by x power l whole power m multiplied with x power l by x power m whole power n. Okay, so this is what we have. And here again, if you have a look at the second subdivision also, the questions are looking little huge in size, right? Okay, so though they are looking huge, little larger, the way of solving them is going to be very easy only. Okay, yes, we are going to get the answers very easily. Just within some 2 or 3 steps we will be getting the answer itself. So how we are going to do that, by what approach? You just carefully observe it here, you will be able to get that. So yeah, coming here to the first question, we have here a fraction, okay, x power m by x power n raised to the power l. Oh, so this is what we have here. So we have a fraction raised to the power l, and we have the property says like when we have a fraction with a common power, what we can do here is we can distribute this power to both numerator as well as denominator. We can do that, right? Okay, so if we try to do that, what will happen? So x power m by x power n whole power l. Now this l comes to this numerator first, so it will become x to the power m into l. So x to the power ml, it will become divided by, now come to the denominator also. Denominator also the same thing happens, x power n into l. So it will become x power nl, it will become like this, multiplied by, next is we have x power n by x power l whole power m. So here also this m will be distributed to both numerator and denominator, so that we will be getting x to the power m into n, it will be mn, by x to the power l into m, it will be which will be l ml, into, next what we have is like we have x to the power l by x to the power m raised to the power n. Here this n will be distributed to both numerator and denominator, so that we will be getting x to the power nl divided by x to the power mn. So this is what we will be getting when we distribute these powers inside. Okay, so now if you have a closed loop, it is going to be very easy, is it or not? Why? Because I have x power ml here, x power ml here, they get cancelled, and next we have x power mn, x power mn, they will cancel, and x power nl, x power nl, they will cancel. So that means we are left with everything is 1 into 1 into 1 only. So final the answer will also be 1. Very simple, right? So 1 is going to be the answer for this question. Question number 9th first subdivision. Answer is 1. It's going to be 1. Very simply we just got the answer within 2 steps, right? Okay, so this is why I told, like, even though it is looking little complicated, the way of getting the answer is going to be very easy when we carefully use the axioms, the laws of the exponents. That's it. Okay, now we'll come here, this second question. So here again, let's try to handle the same way, but this question looks little challenging than compared to the first subdivision question. So anyways, we'll see what is here. So we have x to the power a plus b by x power c raised to the power a minus b, the entire thing raised power minus a minus b. Next is we have x power b plus c by x power a whole power b minus c, and last one we have x power c plus a by x power b whole raised to the power c minus a. This is all we have here, right? Okay, so here again I am going to do the same thing what I did here. So I am going to distribute the outer powers inside to both numerator and denominator. This is what I am going to do. So how I am going to do that, just listen carefully. So first we will have x to the power, Here we have already x power a plus b. The first numerator we have a power x, a plus b is there, a plus b is there. Now that a minus b is also getting multiplied with that. Okay, yes. Divided by denominator, what will become? X power c into a minus b. It will become like c into a minus b. I hope it is clear to you. And multiply it with second one. What do we have here? We have second one to be x to the power, we have b plus c. So b plus c will be multiplied with this b minus c. So b minus c. Now divided by denominator also we have x power a with this b minus c is multiplied. So this will what happen, and since we don't have extra space, I am going to continue it here. Okay, multiplied with. So come here we will have x to the power, we have x to the power c plus a multiplied with c minus a, c plus a multiplied with c minus a, divided by denominator also it will, the same thing will happen, x to the power b into, it will become c minus a. Alright, okay, everything is fine, right? Okay, so far what I have done is distributed the outer powers inside to each of those fractions. That's what I have did here. So now it will be equal to, listen carefully, now it will be equal to, now again deal with the individual fractions. Okay, come to the first fraction and now see the numerator. Numerator we have x to the power a plus b into a minus b. What do you think about that? A plus b into a minus b. It's a well-known algebra identity, right? Algebra quadratics identity. So a plus b into a minus b is nothing but this will become x to the power a square minus b square divided by, and what about the denominator we have? Denominator will become x to the power. Here we have the c which can be multiplied inside. So when we multiply that c inside, we have ac minus bc. I hope you are able to understand this. A into c, the c into a is what is ac, c into b is what is this bc. Okay, this is what I have done here, multiplied with. Come to the second one. Okay, second fraction. Here again we are going to do the same thing. So we'll get a denominator, okay, a fraction. We'll have the numerator to be x to the power b plus c into b minus c. That's nothing but b square minus c square. Like how we had a plus b into a minus b as a square minus b square. Same way here we have b plus c into b minus c. That will become b square minus c square, and which should be divided by x to the power. What about this a multiplied with b minus c? That will be nothing but bring that a inside. So we'll have ab minus ac. I hope it is clear to you. Next we have x to the power, x to the power. Here again we have c plus a into c minus a, which is c square minus a square divided by this b you multiplied inside. So bc minus ab. Okay, I hope you are able to get everything here. So this will be now equal to, again we have to do a very careful step, very simple. Now take a whole numerator and denominator. Okay, so this is what we are going to do now, a whole numerator and a whole denominator. What I am going to do here is I am going to multiply all the numerators and multiply all the denominators. This is what I am going to do. So when you try to multiply all the numerator terms, what will happen is we have x into x raised to the power a square minus b square into x power b square minus c square into x power c square minus a square. So we have all the numerator terms to be with the x's base, right? So that means what I can do here is I can write as x as a common, and when I have multiplication, what can be done with the powers? We can add the powers up, correct? So we can do it like x to the power a square minus b square plus b square minus c square plus c square minus a square. I hope you are able to understand this. So why I am doing like this is like I am just adding all these powers, a square minus b square plus b square minus c square plus c square minus a square. That is what I am doing here in this numerator part, and the same I am going to do it for the denominator also. Denominator also I am going to multiply all these denominator terms like x power this one, x power this one, x power this one. When I try to do that, what will happen now is here x power, what about this? This is AC minus BC, this is plus AB minus AC, plus this is BC minus AB. I hope you are able to follow this, right? Yes. So I am just adding up these denominator powers. Okay, this one, this one, this one. I am adding this. I am just putting them together. Right, I am writing it. Just I am using the first law only. That's what is giving me like this. So now I will be getting x to the power. So it's going to be very simple now, right? What is this x to the power? This is going to be simply 0 divided by, here also denominator is also going to be x to the power 0. I hope you can catch that, right? Why? Because like see all the terms, we have got totally 6 terms and they are going to be positive and negative pairs, right? Okay, for instance, if you take this a square, I can cut with this minus a square plus b square minus b square plus c square minus c square. They will be getting cancelled. You will be left with only x power 0 in the numerator part. Same thing, denominator also come to the denominator. Here we have plus ac minus ac plus AB minus AB plus BC minus BC, they all get cancelled. So you will be left with x to the power 0 again. So that means the answer is going to be like 1 by 1, and that's going to be finally 1 is going to be the answer. So yeah, it will be clear to you, I hope. So here also, with the use of simple algebra identity and then the simple property of this exponents, we are trying to simplify this. No complications at all. If you do it carefully, you can easily achieve the answer. Okay, yes. So that means for both these answers, we are getting the same answers, 1 and 1 here. So they are going to be the answers for this question. Question number 9. I hope it is clear to you. Yeah, next we'll move on to the next question. Next is question number 10 with us. Here we have prove the following. Again, we got two subdivisions. We have to prove them. So taking the first one, it says a plus b the whole power minus 1 multiplied with a power minus 1 plus b power minus 1, it is equal to 1 by ab. So we have to prove that this side is equal to this side. So I think we can start from the left hand side. Okay, so we'll have the LHS. So LHS, we have a plus b power minus 1 the whole raised to the power minus 1 multiplied with a power minus 1 plus b power minus 1. Okay, yes. So in other words, they would even call this as inverse. They would use the word inverse. Okay, so power minus 1 is how you can call this, like you can even use the word inverse. Okay, so like for an example, if I just want to write it and show you, I can just show it as x power minus 1. You call this as, in words you read it as x inverse. Okay, so it simply means like the inverse of x, that is the reciprocal of x. Okay, because both are same only, right? That's the reason. Okay, yeah, anyways, coming back, we can read this as a plus b the whole inverse into a inverse plus b inverse. Okay, we can even read it like that. Okay, yes. So yeah, let's continue. So now this is nothing but a plus b the whole inverse is nothing but 1 by the entire thing, I mean a plus b. Yes, you are able to observe it, right? Yes, is it or not? Because 1 divided by a plus b, because we know that we can reciprocal it so that the power will become positive. I mean like power will become 1, and that 1 is what is simply but a plus b the whole power 1. That is what is a plus b, right? That's what I've written like this. Okay, yeah, here coming here, the next term what we have here is we have a bracket, and this says a inverse plus b inverse. So that means here we have 1 by a plus 1 by b. All right, okay, yes, this is what we have. So this is equal to 1 by a plus b multiplied with, here we have got 1 by a plus 1 by b. So this can be simplified as, I can just take the LCM of the denominators. So when I try to do that, I will be getting AB here, is it or not? I can get AB here. And what about the numerator's position? I will have this B coming here, B plus this A coming here, A. Okay, because 1 times of B is B plus 1 times of A is A. So you have this, and anyways addition is commutative, right? We have 1 by A plus B into B plus A by AB here. So this A plus B and this B plus A both are same. I can just directly cut this A plus B and B plus A because both being same, that's why. So we are left with 1 by, simply 1 by AB. This is what we are left with, and no doubt that is what we have in the right hand side also. So this is equal to RHS. So simple, we have shown that LHS is equal to RHS. Okay, done with the first subdivision. And now coming here to the second subdivision, here again we have to show x plus y plus z whole divided by x inverse y inverse plus y inverse z inverse plus z inverse x inverse. It is equal to the product of x, y and z, that is x, y, z. This is what we have to prove. Again, we will just start with our LHS. Left side, we will start with left hand side. So here we got x plus y plus z divided by, I think I can minimize the step here itself, right? Okay, so I can minimize it. So first of all, basically what I can do here is like we have x inverse, y inverse, right? So that can be rewritten as xy the whole inverse. You agree with that? Yes, because like when we have two numbers raised to the same powers, we have a common it. So what we can do is like when we have a product of that, what we can do is like we can just take the product and then write it as a common power. Like this rule says like this rule, okay, AB the whole power n will be equal to A power n into B power n, and we have here like A power n to B power n. That is what we are rewriting it as AB the whole power n. That's simple. Okay, so here is like x and y, they have the common powers, they are getting multiplied. What I can do is I can just take xy the whole inverse. That's all. That's what I'm doing here. So continue, plus here again we got y inverse z inverse. So this can be rewritten as yz the whole inverse, plus, so this can be written as xz zx the whole inverse. Hope you got it. Okay, yes. So this is what we have here. So this left hand side I'm just writing here, I'm remodifying it. Okay, yes. Now as continuing it, I will get x plus y plus z whole divided by, what about this denominator term? We got xy the whole inverse, which is nothing but 1 by xy plus this yz inverse can be written as 1 by yz plus this is 1 by zx, is it or not? So this is what we will get. So now continuing it, we'll have x plus y plus z as usual. Don't disturb the numerator. Numerator we will have it as it is, carry it as it is. Okay, don't disturb. And coming to denominator, denominator is what? We have to simplify. Okay, yes. So 1 by xy plus xy plus 1 by yz plus 1 by zx, this is what we have. So we can take as a common denominator, we can take the LCM of that. So we got denominators as xy, yz and xz. This is what we have, right? So what we can go for it, the common denominator will be xyz. Yes, you agree with that, because xyz. So we can take xyz because in each of those only one term is missing. So when we try to insert this, that will become the common denominator, xyz, that will become like that. And now if you take xyz is here, we have xy in the first fraction. So when this is getting multiplied with z, we can achieve this denominator, right? So the same thing happens. So numerator also will get multiplied with z. So this will become z plus, what about the second one? Here we got yz here. So in order to multiply this with x, we will be getting this, right? If we multiply this with x, we will be getting this denominator. So the numerator also will be getting multiplied with the x. So x plus, and last one we got zx. So we need to multiply it with y, and so the same thing happens for your numerator also. So y. Okay, yes. So now we got a step something like this. And now what we can do here is, I can do it like x plus y plus z, we will have it as it is. Now what I'm going to do is, I have a denominator which is expressed in terms of a fraction. I will take the denominator of the denominator to the numerator. We can do that, right? So whenever a fraction we have, and we have a fraction where the denominator is again a fraction, so the denominator's denominator we can bring it to the numerator position. We can very well do that, right? When we try to do it, this xyz will come here, xyz. Okay, xyz divided by, and what about this one? This is nothing but x plus y plus z. Okay, if I try to write it in order, x plus y plus z, it will become x plus y plus z. And now simply we can cut this x plus y plus z, both the numerator and denominator, and we are simply left with only this product xyz. So it is equal to xyz, and that is what is nothing but here RHS. Yes, okay, fine. I hope it is clear to you. So both these things, both these subdivisions, we are easily able to prove it, right? Okay, just by using the properties of the laws of exponents. So successfully we are able to show like LHS is equal to RHS. We have proved it, right? Yes, yeah, thus they are proved. Yes, fine. We'll move on to the next question now. Here is question number 11 with us. Another interesting question we have. Given if A is equal to C to the power Z, B is equal to A to the power X, and C is equal to B to the power Y. So that is, there are three values A, B and C. They are interrelated within themselves, right? Among themselves they are related. So what we are asked to do here is, like, we have to prove that X, Y, Z is equal to 1. That is the powers we have, right? The power values, the product of the powers is equal to 1. This is what we are asked to prove here. Okay, so let us see how easily we are going to do this problem. Okay, there's nothing much to complicate here. Okay, so the idea is we have to start from any one of these values. Okay, so suppose we have A is equal to C to the power Z. Okay, so this is what is given, right? Let's try to start from A is equal to C to the power Z. We'll start from here. So now what next we can do here is, A is equal to, we just simply go for the C to the power Z. This is what is expressed, right? Now go for C. See what expression is given here for C. So if you see here, C is equated to B power Y. Okay, yes. So that is, the C is equated to B power Y. Let me just try to use this substitution here in the place of C. I'll try to do it. Okay, yes. So once we try to do it, we can replace this C by B power Y. Hope you are able to get that, right? Okay, so B power Y. The C I am replacing by B power Y. Once again, this whole raised to the power Z. Because the C power Z, right? The C alone I am taking it as B power Y, the whole power Z. This is what is happening. Okay, fine, yes. So now this will be A is equal to B to the power YZ. Fine, okay, because we got power of power, we can just get the multiplication, we can product it. Okay, we can get the product. b to the power yz, it will become b to the power yz. And once again a is equal to, now this a which was expressed in terms of c is now expressed in terms of b. A is equal to b power yz. This is how it became, right? Okay. Now again go back to the definition of b, how b is expressed. If you see here, b is expressed as a power x, right? Okay. Now let's try to use this definition. Okay, yes, I think I can come like this. Yes, let's try to use this definition for b here. Okay, I hope it is clear to you. First I use c's definition here in the place of c. Now I will use b's definition over here in the place of b. So that is, now this b is equal to a power x. Now I am going to replace this b by this a power x. So what will happen is, so this will become a power x to the whole power yz. I hope it is clear to you. A power x to the whole power yz. So this will become a is equal to a to the power. Now again, power of power we have, we can just multiply the powers, we will get a to the power x yz. That's it, very simple. Okay. Now we see here, finally what happened is this a is expressed in terms of, once again, a's power itself, right? Okay. So a is equal to a to the power x yz. This way we got finally. And see this left hand side, this left hand side is nothing but, it's very simple. This is a, right? I can even write this a as simply a power 1. I can do that, right? So a power 1 is equal to a to the power x y z. So now you got the same bases, but they have different powers. It is going to be equated. So what happens is, when we have the bases same, when they are equal to, the powers will also be naturally obviously same. That is, I can even equate the powers. Okay, when we have same bases, powers are different. I can even equate the powers. So when we try to equate the powers, we will be getting this xyz is equal to this one. Okay, so this is what is the result we can derive from this previous expression. Why? Because we know that a power m is equal to a power n. Because if a power m is equal to a power n, I can equate the powers, right? Using that rule is what, that law is what I am doing this. This xyz is equal to this one. So finally we are able to show that xyz is equal to 1, and that is what is asked us to prove here in this question number 11. And that's it. Hence we have proved that this xyz is equal to 1 here in this question. Yes, now we'll move on to the next question. Next is question number 12 with us. Here this question is, if a is equal to xy to the power p minus 1 and b is equal to xy to the power q minus 1 and c is equal to xy to the power r minus 1. So they have given expressions for a, b and c, all of them in terms of x and y. Okay, yes. And in all of them we can see that y's power is raised. Okay, it is not whole power. Okay, xy to the power p minus 1 is like x's power is 1 only, but y's power is what is that, p minus 1. Here again that x's power is 1, y is q minus 1, and here again like that. Okay, so this is how a, b, c are expressed. And what we are asked to do here is prove that a power q minus r into b power r minus p into c power p minus q is equal to 1. So we'll better start from the LHS. Okay, so we should carefully deal with this question. So what we have in our LHS is, we have LHS to be a power q minus r into b power r minus p into c power p minus q. This is what we have. So we have to start from here, and we will just try to simplify, and then finally we will try to get that 1, and hence that will prove that this proof. Okay, that will show that will be equivalent to proving it. So now what we can do is we will start from the left hand side. So left hand side we got a powers, b power, c power, right? Okay, so what we will do here is, already in the question itself we are clearly defined with what are a, b and c. Here itself we are defined. So everything is defined in terms of x and y, is it or not? So we will just substitute those expressions here in the left hand side, and from there we will start our LHS. Okay, so once we try to do that, what happens is, this a can be replaced as xy power p minus 1 the whole power q minus r. I hope you are able to understand this, because a power q minus r is like xy power p minus 1 the whole power q minus r, right? Okay, because this a is equal to xy power p minus 1, right? That's what. Okay, multiplied with, I can even replace this b by this above expression. So we have xy power q minus 1 the whole to the power r minus p, and last one we have xy to the power r minus 1 the whole to the power p minus q. Hope you are able to understand this, right? Okay, so respectively I am replacing a, b, c with the above given expressions. This is what I am doing. So now this will be equal to, so now we have everything expressed in terms of x and y only, right? I mean all these expressions is of the powers of x or y. That's how we have this. So now what I'm going to do is I will just take this powers inside. Okay, so I will get x to the power q minus r, x to the power q minus r into y to the power p minus 1 into q minus r. Okay, I'm just distributing this power q minus r to both these terms. That's what I'm doing. I'm getting this step. Same way I will do for here and here also. Okay, so yeah, here what will happen is x to the power r minus p times y to the power q minus 1 into r minus p. Hope you can understand this. And last one we have x to the power p minus q, x to the power p minus q multiplied with y to the power r minus 1 into p minus q. So this is what we will be getting. So now what I can do here is I will just take this x terms to one side. I mean, like I will just take that x terms together. Okay, we can tell it to be together. That will be an apt word. So like I will take this x's power everything together. Okay, so if I try to do that, I will be getting x to the power q minus r into x to the power r minus p into x to the power p minus q. This is what I will be getting. And now I can do the same thing for the three y terms also. Y power, y power, y power we have, right? That also I can put them together. Okay, I can put them together. Okay, so this is like these three terms are put together, and next three terms are like y's powers are there. Okay, yes, so we will carefully do it. Okay, y power, see here the first term y power we have p minus 1 into q minus r. This is what we have, right? So what we will try to do here is we will try to multiply the powers, because we have power. So two powers, I mean like the power is there, right? This is a product, right? I'll just multiply it inside so that we will be getting it to be, carefully do it, okay? We'll be getting it to be, they are binomials, right? We should carefully multiply. So p minus 1 into q minus r, if I try to multiply, I will be getting it to be like pq. First I will get p into q to be pq. Next p into minus r will be minus pr. Next I will have minus 1 into q will be minus q, and this one minus 1 into minus r will be plus r. I hope you're able to understand what I'm doing here. So I'm just multiplying these two terms here, and that is what is giving me y to this expression, y to the power of this expression. Okay, yes. Second, next y to the power, come to the second term. Okay, here we have the multiplication of q minus 1 into r minus p. So this is what we have here, right? Here again, let's try to do the same thing. Okay, if we try to do it, we'll be getting y to the power qr. Next we have minus pq. Next we have minus r. Next we have plus p. I hope you can understand this. I am multiplying this q with these two and this minus 1 with these two. That is what is giving me this result. And last one more, y to the power. Here again I can do that. Okay, so third term of y is there, right? So here I can again I will do the same thing. So this r minus 1 into p minus q I am going to multiply now. So I will be getting pr. First will be pr. Then p into minus q, r into minus q will be minus qr. Next minus 1 into p will be minus p, and last one we have minus 1 into minus q will be plus q. Okay, so this is all I will be getting. Everything is so far clear, I think. So I will close the bracket of this y terms also. So first three terms are x and the next three terms are y's powers. Okay, this is how we have. So now what I can do is, since they are getting multiplied, okay, x power, x power, x power, they are getting multiplied. What we can do here is I can just simply I can add all the powers, right? I can just add these powers. Okay, I will be getting x to the power q minus r plus r minus p plus p minus q. This is what I will be getting here. And now next here for y also I can do the same thing. Okay, so we have very long expressions here. We should carefully do it. Okay, very carefully we have to do that. So y to the power, just see all these expressions, we can just multiply it like pq minus pr minus q plus r. Again the second one plus qr minus pq minus r plus p. Again we have plus pr minus qr minus p plus q. So this is what we have entirely. Okay, so if you see carefully, totally there will be 12 terms here. Why? Because we originally had 2 here, 2 twos here. So each of them is giving you y's power 4 terms, y power 4 terms, y power 4 terms, and finally when we come to multiply everything, we are getting y to the power a total of 12 terms we are getting. Okay, yes. So I think it will slightly confuse you, like but if you try to distribute the variables carefully, if you multiply it everything, you will be clearly getting the things. Okay, there's nothing to worry about it. So yeah, continue. X is equal to x to the power. Now what about the x powers? It's going to be very easy, right? You can easily say that this minus p plus p, then plus q minus q, plus r minus r, they will be cancelled. So you will be left with only x to the power 0 into y to the power. Come to the y to the powers, we will carefully search the same things. Okay, so what are the terms we can just cut like this. So we will search same magnitude but positive negative signs, plus and minus signs. We'll search for that. So if you try to do that, we'll be getting plus pq and minus pq, they both will be going off. And any other things like this, yeah, we have a minus pr plus pr, they will also be going off. And we have a minus q here and a plus q at the last, that will also go off. And similarly we have a plus r and minus r, that will also be going off. And we have plus qr minus qr, that is also out. And finally plus p and minus c, that minus p, that is also out. Finished, everything is finished, right? So that means here again we are getting y to the power simply 0 because everything is cancelled off, right? So that means x to the power also 0, y to the power also 0. So this is simply nothing but 1 into 1, that is going to be 1. So answer is going to be 1 here. So this, when you try to simplify the final answer, we are getting it to be 1 here. And so that is what is equal to our right hand side also. So we have successfully proved our LHS is equal to RHS. So we have successfully proved this question also. So yeah, this is going to be the solution. I hope it is clear to you. Just have a look. Okay, just have a look on this part also. You try to work it out individually, you will definitely get the answer. So hope you will be able to, you are able to follow the steps very carefully. This is about the proof for this question. Yes, we'll move on to the next question. Next is question number 13 with us. Here our question is, if 2 raised to the power x is equal to 3 raised to the power y is equal to 6 raised to the power minus z, then prove that 1 by x plus 1 by y plus 1 by z is equal to 0. This is our question. So here this question, we have some relation between these values, that is 2 raised to x, 3 raised to y and 6 raised to minus z. Now all these three expressions are equated. So, and we are asked to prove something which is based on the powers. So except this, there's no other thing which is given here in this question. So let's try to handle this question much technically. Okay, yes. So what I'm going to do here is, just listen carefully what we are going to do here. So first of all, let us start from what is given to us. Okay, yes. So we will have 2 power x is equal to 3 power y is equal to 6 power minus z. And I'm going to introduce a new variable which is going to be equal to some k. So that is, since everything is equal, all these expressions are equal, I am going to take or equate them itself to another variable which is going to be k. This is what I am doing. So now if you individually, if we just try to individually compare, what we will get here is, we will be getting 2 power x is equal to k, we will be getting. Next we will be getting 3 power y also is equal to k, and 6 power minus z is also equal to k. We will be getting this way. Is it right? Yes, okay. Yeah, fine. Now what next we will do here is, we will try to take the powers to the other sides. This is what we are going to try now. Okay, yes. Yeah, fine. Now what I am going to do here is, here I am going to try to change the powers. Okay, or I can tell what I am going to do here is, here take the first one, we have 2 power x is equal to k. This one we are going to do something like this. Okay, so I am going to raise both these powers by 1 by x. Let's see what will happen. So this will become like 2 power x whole power 1 by x is equal to k power 1 by x. This is what happens here. And next here what will happen is, 3 power y whole power 1 by y will become k power 1 by y. And last one, this will become 6 power minus z the whole to the power minus 1 by z. Okay, yes, I have a reason for that. This will be equal to k to the power minus 1 by z. So why we are doing all these things is just to take these terms to be only the base with the powers to be equal to 1. This is what we are actually trying here. Listen carefully again. So see here, if you watch this closely, we have 2 power x to the power 1 by x. So now when we have a power of power, what happens here? The powers get multiplied, is it or not? So that what happens is, we will be simply getting only 2 power 1. Because this x into 1 by x, it will be getting multiplied and we will be having 1 in the power. So we will have simply 2 power 1, which is going to be just 2. So 2 is equal to k power 1 by x. And similarly here also we will have 3 is equal to k to the power 1 by y. And last one, here we will have 6 is equal to, since here also the same thing happens, minus z into minus 1 by z, they will get cancelled. If they get multiplied, we will have 1. So 6 power 1, which will be 6. 6 is equal to k to the power minus 1 by z. This is what we will have. So now we will try to do another thing. What we can do here is, we now got expressions for what is 2 in terms of k, what is 3 in terms of k, and last what is 6 also in terms of k. We got it. Now we can do a very easy thing. What we can do is, we very well know that the product of 2 and 3 is what is equal to 6. Is it or not? 2 3s is what is equal to 6. That is, this 2 multiplied with this 3 will what be equal to giving you this 6. Is it or not? This 6. Right? Yes. So now what I can do is, that means the right hand side also should be obeying. It should be satisfying the same property, right? The same product, right? So let's try to do the same equation with the right hand side. Okay. How 2 into 3 is equal to 6? The same way, this expression. What about this expression? This will be k to the power 1 by x multiplied with k to the power 1 by y. This has to be equal to the right hand side, k to the power minus 1 by z. Yes, are you able to take this? This is easy for you to understand, right? Yeah, k power 1 by x into k power 1 by y is equal to k to the power minus 1 by z. It's simply 2 into 3 is equal to 6. I have just taken the expressions in terms of k. That's it. Now what next we can do here is, like, now we can just take the left hand side and we can have the multiplication. We are having the multiplication, right? So when you have the same base and when they get multiplied, what happens to the powers? Powers, they get multiplied. So we will have k to the power 1 by x plus 1 by y is equal to k to the power minus 1 by z. This is what we will have. And what next we can do is, now both our left hand side or right hand side are in terms of k power something. Now what we can do? We can very well equate the powers itself. Since the bases are same, what we can do? We can just equate the powers also, right? Okay, so power. So we can equate the powers. So what we can do now here is, I am going to equate. Let me take a line here. So I'll continue here. I am going to equate this power left hand side 1 by x plus 1 by y is equal to the right hand side. Right hand side, what do we have for k power? We have minus 1 by z. We can equate it like this. Simple. And now last step what we can do is, we'll try to bring this minus 1 by z over here to the left hand side. We will be getting 1 by x plus 1 by y plus 1 by z. That will be equal to, there will be nothing on the right hand side. So that means it will be equal to 0. And finally, this is what we are asked to prove here in this question. So we made it simple. Okay. The only thing technically what we are doing here is, since we don't have any other thing in this relation what is given here in the question, we ourselves introduce another variable k, and with the help of k we are just trying to express all these numbers in terms of k, and then we do it in the powers of k, then compare the powers and get the result, get what we are asked to prove here. This is all we are doing it. So again, just try to see this problem from the beginning. Just rewind the video and just try to see this problem, how the approach we are solving it, and you also try to do it once more. Okay, try to do it by yourself. You will really be able to understand this. Okay, so since this is going to be a slightly different approach than the previous questions, so this way we are handling it to solve this problem. So yeah, so this is going to be the proof for this question. So yes, successfully we have proved, hence proved this proof also. Yes, we'll move on to the next question. Next is question number 14 with us. So again, very similar to our previous question only, question number 13. So let's see what is here in this question. Given if 2 to the power x is equal to 3 to the power y is equal to 12 to the power z. So if this is given, then prove that x is equal to 2yz divided by y minus z. This is going to be our question. So as I told, it is almost similar to the previous question. Okay, so how we got a relation there in the previous question, the same way here also we are again getting a relation. Okay, yes. So as usual, we will start from what we are given. So we have got 2 power x is equal to 3 power y is equal to 12 power z. So this is equal to, let's say it's equal to k. Like how we related to a new variable, we introduced a new variable there, k. Same way this question also I am going to take the similar way. Okay, all right. And as usual, what happens is 2 power x will be equal to k. Okay, 2 power x will be equal to k. 3 power y is equal to k, and 12 power z is also equal to k. Fine. Okay, all right. Yes, done. Now again, what I am going to do here is I am going to express this 2, 3 and 12 in terms of k, just by bringing these powers to the other side. Okay, yes. So I am going to just do it directly. So what happens is, if I take powers on both the sides, like 1 by x raised to the power 1 by x, what happens is, like here we will get 2 is equal to k to the power 1 by x. And the second one, we will get 3 is equal to k to the power 1 by y. And here we get 12 is equal to k to the power 1 by z. I hope it is clear to you. So we are raising both sides by power 1 by x here. Here we raise both the powers by to the raise to the power 1 by y on both sides. Here 1 by z, raising to the power 1 by z on both the sides. So this is what we will be getting, and we are getting a relation like 2, 3 and 12. Everything is expressed in terms of k's powers. This is what we are achieving here. Yes. Now what next we will try to do is like how we related the previous question. There we had 2, 3 and 6, right? So how we related the 2, 3 and 6? It's simply like 2 into 3 is equal to 6. We used that step and we used that relation, right? Yes. So here again we have to express this 12 in terms of this 2 and 3. Let me repeat that how we used 2 into 3 as 6. Here also we have to relate this 2 and 3 as this 12. Like this 12 I have to express in terms of 2 and 3. So how can that be done? So can you write this 12 as a product of powers of 2 and 3? How can that be done? So this 12 is nothing but 4 3s are or 3 4s are, is it or not? And once again that 4 can be written as what? It can be written as 2 square. So finally we can simply write this 12 as 2 square into 3 is equal to 12. I hope it is clear to you, right? Yes. So see, you can check it now. 2 square 4 3s are is what is this 12. So our attempt here is like we are trying to write this 12 as a product of powers of 2 and 3. This is what we are trying. Why we are doing this? Because we have a relation of 2, 3 and 12 in terms of k. That's why. Okay, all right. Now let us use this relation to get our proof. Okay, all right. Yeah, let's do that. So first step what we can do here is 2 square into 3 equal to 12 is what we have as of now, right? So express everything now in terms of k. We will do that now. Fine. Okay, now we got 2 square. Okay, yes. So 2 square will be nothing but 2 is nothing but k power 1 by x. So that means k power 1 by x the whole square. Alright, okay. This 2 square is what I am rewriting like this. So 2 square is written like k power 1 by x the whole square multiplied by what next we have? We have 3. This 3 is power 1 only. So simply I can replace this 3 by k power 1 by y is equal to, right hand side we got 12, right? So this 12 is equal to k power 1 by z. 12 is equal to k power 1 by z. We can write it like this. Fine, done. Okay. Now what next I can do? Here I got power of power, so I can just multiply the powers. I can multiply this 1 by x into 2, so that I'll get k power 2 by x into k power 1 by y equal to k power 1 by z. This is what I will get. And next what I can do, I have my left hand side with k's powers getting multiplied. So what we can do here is k power, we can just add the powers, is it or not? So we will be getting like 2 by x plus 1 by y is equal to k to the power 1 by z. This is what we will be getting. So finally we expressed our LHS as well as RHS. This expression, both these sides are in terms of k's power something only. K power 2 by x plus 1 by a is equal to k power 1 by z. So at this situation what can be done? We can very well compare the powers. Okay, since the bases are same, I can just compare the powers, is it or not? So when you try to compare the powers, we will be getting what? We will get 2 by x plus 1 by y is equal to 1 by z. This is what we have. Okay. And one more thing, what we are asked to prove here, just look at the question. We are asked to prove x is equal to 2yz by y minus z. This is what we are asked to prove, is it or not? So that means it will be comfortable if we keep that x term on the left hand side and we'll take that y and z terms to the other side. Okay, yes, we'll try that. So we'll get 2 by x is equal to, this side we'll have 1 by z, this plus 1 by y will go there, it will become minus 1 by y. Alright, yes, done. Now, yeah, continue. I can even simplify this, right? If I want to simplify this, I will write this as denominator will become yz and numerator will become 1 into y minus this will become 1 into z, this will become z. So that means we got 2 by x is equal to, you just leave this intermediate step, okay? This is what we have transformed like this. So we get directly compare these two, okay? 2 by x is equal to y minus z by yz. This is what we are having, is it or not? So that means, let me try to exactly write the reciprocal. So if I try to do that, this will become x by 2 is equal to, this will become yz by y minus z. Yeah, done, yes. And last, just one more step, what we can do here is, I can bring this by 2 to the other side, it will become 2 into yz, okay? This 2 goes to the numerator. divided by y minus z, and that will finish the proof. Okay, because exactly this is what we are asked to prove here in the question. And yes, success, hence proved this question also. I hope it is very clear to you. So if the previous question is very clear to you, this question can also be done the same approach. You will easily get the answer. The only thing is we have to carefully relate the numbers. Okay, that's what is very important. If you are able to do that, then in a line, okay, step by step, you can easily get the answer. Very easily you can just get this proof. Yes, hope yes you can understand this, I think. Yes, let's move on to the next question. Next is question number 15, a very simple question, right? Evaluate the value of x power half into y power minus 1 into z power 2 by 3. Given the values of x, y, z here. So x is equal to 9, y is equal to 2 and z is equal to 8. A very direct question, is it or not? So all we need to do is that just we have to substitute these values, respective values over this expression here. Okay, so like we'll be getting it to be the value is equal to, let me just directly come to the solution. So we'll be getting like x is equal to 9, so that means put x is 9 here. So we get 9 power half multiplied by y. What is y? Y is 2 power minus 1. Then z, what about z? Z is 8 power 2 by 3. This is all we have here. So what next we can do here is like we can bring this 9 power half as square root of 9. We can do that, right? Yes. Multiplied by, what about 2 power minus 1? 2 power minus 1 will be 1 by 2 power 1. That's simply 2. Okay. Into, what about this one? 8 to the power 2 by 3. We got 8 power 2 by 3. So we try to do it like cube root of 8. Okay, fine. Because this by 3, powers by 3, if you take it to the front, it will come as like a cube root of 8 raised to the whole power. 2 alone will be there in the power. Okay, all right. Yeah, continue. We get here root 9 to be 3 into, this is 1 by 2 as it is 1 by 2 into, what about cube root of 8 here? Cube root of 8 is going to be 2 only, right? Because 2 into 2 into 2 is what is 8. So cube root of 8 is 2 and this 2 is squared. So we have 4. So it's not going to be a very complicated calculation. Hope you can understand it because we have very small numbers only. Cube root of 8 is 2 and the 2 square is 4. I'm just applying it directly. So what we will be getting here is like I can just cut this 2 and 4 exactly 2 times. So we'll be having 3 into 1 into 2 which is 6, and 6 is going to be the answer for this question number 15. Next we have question number 16 with us. Here our question is, if x to the power 4, y to the power 2, z power 3 is equal to, the product of these terms is equal to 49,392, then we are asked to find the values of x, y and z if they are all different prime numbers. So that is this x, y and z, all three those variables are going to be, the values of those variables are going to be like all are different prime numbers they have given. And if x power 4 y square z cube is equal to 49392, we have to find their values. This is going to be the question. So actually this question is going to be a very simple basic question only. So we can try solving this question just by factorizing our number, the number that we see in the right hand side. Okay, yes. So let me start directly. So I'm going to take that number 49392. So we are going to start from here. So I'm going to factorize this number. Factorize in this sense like we do step division, right, in our younger days. So in that way we are going to factorize these numbers. This is what we are going to do here. So we can factorize these numbers with prime numbers because they have just given the condition to be they are all prime numbers. So for that reason we will just use all prime numbers and factorize this so that we can easily get the values of x, y and z. Okay, ready? Yeah, fine. So I think we can better start from the least prime number, that is going to be 2, and it is very clear that our number is also divisible by 2. Yes, okay. Yeah, fine. So we can go for this 2 tables. Okay, so in 2 it is going to be exactly 2 2s are 4, and next we have 2 4s are 8. So balance 1, 2 6 are 12, balance 1, 2 9s are 18, balance 1, and 2 6 are 12. That's it. We got it this step. And once again I can go for 2. So we will be getting like 2 12s are 24, we can directly go, and 2 3s are 6, and 2 4s are 8, and balance 1, 2 8s are 16. So we're getting like this. Again we can further go with 2 tables itself. So when we try to do this, we'll be getting 2 6 are 12 because we have 1 here. So we have to take this entire number 12. 2 6 are 12, and 2 1s are 2, and balance 1. 2 7s are 14, and 2 4s are 8. Yes. And again we can go with 2 tables itself. So when we try to do it, we'll be getting 2 3s are 6, and next we have 17, okay, because we have 1 here, so we have to see the number together. 17, so 2 8s are, so how do we write that 8? 0 8 we have to put, okay. 2 8s are 16 and balance 1 is, so we have 14, so 2 7s are 14, okay. That's it. Again, we can't proceed with two tables because we are now getting an odd number. So now we'll go for the next bigger prime number, okay. So we completed 2. The next prime number is going to be 3 only, right? So let's try to just divide it by, factorize by 3, okay. So we'll be getting 3 10s are 30. This entire 30 will be 3 10s are 30, and we got 87 here. So 3 2s are 6, balance 2, 3 9s are 27. We are getting like this, and once again we can go for we can go for 3 tables itself. So we try with 3 tables. We'll be getting 3 3s are 9, balance 1, 3 4s are 12, and we have 3 3s are 9, again sign, okay. So we are getting 343. So if you are very much strong in powers, and that too particularly cubes, you can easily just recognize this 343. This 340 is nothing but, it comes in 7, right? Okay, so I'll show you that. So 7, so next prime number will be 7, because this 343, it will not be divisible by 3 hereafter. So 2 is gone, 3 is gone. Next prime number will be 5, but it is very easily visible that we can't divide 343 by 5 also. So the next number, we'll go for 7. So 7, this is definitely divisible, we can test it. 7 4s are 28, and balance we will have 6. So we'll have 7 9s are 63, and once again by 7 7 7s are 49. That's it, finished, okay. So finally we have completed all the steps in factorizing our original number 49392. That means 49392, this can be finally written as what? This can be written as, see how many 2s are here? There are 4 2s are here, is it or not? 1 2 3 4, there are 4 2s, so 2 to the power 4 multiplied by, come, you see how many 3s we have here? 3s, there are just 2 3s are here, so 3 power 2 we have, and finally multiplied by, we have 3 7s here, so we have 7 power 3, okay, alright. So this is what we are getting when we try to expand, or when we try to factorize our number 49,392. So we are getting it to be 2 power 4 into 3 power 2 into 7 power 3, and if you try to exactly match our question also we have the same way, okay. So how is this 49,392 given? It is given in the form of x power 4 and y power 2 and z power 3. This is what we have it, right? Yes. So I can very well write it as x power 4 into y power 2 into z power 3 is same as 2 power 4 into 3 power 2 into 7 power 3. If at all I am just having prime numbers here, so definitely when the powers are same, we can appropriately compare and then get the values of x, y and z. The respective values we can get, okay. So x power 4, 2 power 4 we can compare, we'll get x is equal to 2. This is one value, and next y and this 3 we can compare, y is equal to 3. Next, and last one z and 7, so z is equal to 7. So successfully we got the values of all the 3 variables. So these are going to be the answers for our question number 16. Next with us is question number 17. So if you see this question, we have totally got 4 subdivisions here, and we are going to work out all these 4 subdivisions here in this one stretch, okay. Yes, so let's do them one by one. So here if you take the first subdivision, okay, yes, we have 5 power 2x plus 3 is equal to 1, and same way if you see the second subdivision, third subdivision, fourth one, everything you have that left hand side is equal to some right hand side, and everything we have in terms of x. The power value, if you see, powers are like you have in terms of x, and we have to solve these equations, and we have to solve for the value of x. We have to get the value of x. This is going to be this question setup, and how we are going to achieve this, okay, if you ask, it's going to be very simple. We will have to first of all take these equations and try to bring it in such a way that we have both the left hand side and right hand side having the same basis, okay. Yes, we just rewrite them using same basis. So here if you for an example, if you take this first question, we have 5 power something here in this left hand side, right? So the right hand side also we'll have to try to write in 5 power something, okay. If we try to do that, then easily we can solve these kind of questions, okay. So yeah, let's start from the first subdivision. So here our question here is like we have a 5 power 2x plus 3 is equal to 1. This is what we have, right? So what we will do is, first of all, 5 power 2x plus 3 is equal to, what about this 1? As I told, this 1 also we have to try to rewrite as 5 to the power something. So how can this be done? It's very simple. 5 to the power 0 I can write, because we very well know that any number, right, any number raised to the power 0 is going to be 1. So since we have to raise as 5's power, I am taking that to be an advantage. I am writing it to be 5 power 0. This is what I am trying to do. And now after doing this, what we can do? Now it's going to be very easy. So 5 power 2x plus 3 is equal to 5 power 0. So what we can do here is, since the bases are same, what we can do? We can just equate the powers. As usual, we can equate the powers. So when we try to do it, we will be getting 2x plus 3 is equal to 0, and now I can easily solve this equation and get the value of x. Is it or not? So what I can do here is I can just get the value of x to be is equal to, this will be minus 3, this will be 2, so minus 3 by 2 is going to be the answer for our first subdivision here. Okay, quite easy, right? Yeah, the first question was very easy, and as we go, we have got little complicated questions. Let's carefully handle them and solve it. So coming to the second subdivision, here again we have 13 to the power root x. This is what we have in the left hand side. Okay, 13 to the power root x. So this will be equal to, now come to the right hand side. Right hand side we have numbers. Everything is given in terms of numbers, right? So we have 4 power 4. What is basically 4 power 4? So 4 power 4 will be like 4 we have to multiply it with itself for 4 times. Okay, so that means 4 into 4 into 4 into 4. We get 16 times of 16. So which will be 256 minus. And what about this one? 3 power 4 will be, again we have to do it like 3, 3, 3, 3. 4 times we have to multiply. So we will get 9 nines are 81. So 81 minus this will be 6. Alright, okay. Yeah, fine. Now we will be getting 13 power root x is equal to, now what about this value? This value will be equal to 256 minus 81 minus 6. Let's try to do it at a stretch. Okay, so we'll be getting it this to be, so let me write it here itself, right? Okay, so 256 minus 81 minus 6, it will be how much? So like it will be like 256 minus 87. So we'll be getting it to be 9 here, and so we'll be having it to be 24 minus 8 will be like 16. Okay, 169. So this is what we'll be getting for this answer, 169. And now what happens is 13 power root x is, what is this? 169, sorry. So 13 power root x is 169, and now try to rewrite this 169 as power of 13. So this is what we should try to do, and that can be easily done, right? Because we know that 13 square is, what is this? 169. So that means 13 power root x is equal to 13 power 2, and hence what I can do here is, again I can equate this powers, right? Okay, so I will be getting root x is equal to 2, and so x will be equal to what? X will be is equal to 2 square, and that means x is equal to 4. That's going to be the answer, because for which number if you take a root, you will be getting 2. So for which number? So root x is 2 means x is equal to, we have to do a square here, right? So 2 square, so we'll be getting x is equal to 4. This is what we'll be getting. So second one is also over, and as we go, we are getting little complicated questions. Yes, we'll manage to handle them. Yeah, okay, fine. Next, here we got this question, third subdivision, we are getting root of 3 by 5 the whole raised to the power x plus 1. This is what we are having. So let me just change this left hand side itself. So what I can do here is, I will try to do write it as 3 by 5 the whole power. Now what happens? This 3 by 5, it is in root. Now if I try to write it as a power, what will come? It will become like half. Is it or not? It will become half. Half into, already there's one more x plus 1 is there. So half into x plus 1. This is the way it will be becoming. And now come to the right hand side. So this right hand side, how can be rewritten? How can this be done? So if you carefully see, this right hand side we have 125 by 27. Now listen to this. We should express this 125 by 27 also in terms of this 3 and 5. This is our objective. Okay. So if you carefully think here, carefully watch it. So we'll be getting this 125 is to be nothing but, this is nothing but 5 cube. Is it or not? This 125 is 5 cube, and this 27 is 3 cube. So simply I can write this as 5 by 3 the whole cube. Okay, alright. I can very well write like this, right? 5 by 3 the whole cube. If you want to come and check it, 5 cube is 125, 3 cube is 27. Done, right? Okay. Now what I can do here is, but here left hand side what we have? We have 3 by 5. We have 3 by 5 raised to the power something. But right hand side we have 5 by 3. So in order to take both these things to be the same base, what I can do here is, now I can change the right hand side. So right hand side now I am going to rewrite as 3 by 5 the whole to the power. What will be coming? Of course it will be minus 3. Is it or not? Why? Because like I am changing, I am just reciprocal, I am just taking the reciprocal of this value, so that what happens to the power gets its sign changed. Okay, so like we have now, if you see, compare both this left hand side and right hand side. Now both the things are expressed in terms of The same base only, 3 by 5 power, 3 by 5 power. Now we can very well equate these two powers. Okay, shall we try doing that? So we'll get half into x plus 1 is equal to minus 3. Now we can very well solve for x. Very easily we can solve. So when we try to do it, we'll be getting x plus 1. Basically this x plus 1 will be equal to, I can bring this half to the other side. So it will become into 2, right? Because 1 by 2, this by 2 goes there, it will become into 2. So minus 3 into 2 will be minus 6. And finally we will be getting x is equal to minus 6 minus 1. So minus 6 minus 1 will be minus 7. And that's going to be the answer for this third subdivision. I hope you are able to follow this. You can understand this. I'm just minimizing the steps. I'm just writing the steps here itself. I'm just cutting it short. Okay, yes, that's what I'm doing here. And yeah, coming here, last subdivision of this this 17th question here, fourth subdivision. So this one we have cube root of 4 raised to the power 2x plus half. This is what we are having, right? Okay, so here again we are going to employ the same technique. Okay, so this cube root of 4, I'm going to rewrite it as 4 power 1 by 3 into 2x plus 1 by 2. I hope you can understand this, what I'm doing here. So see here, this cube root of 4 is there. I'm just taking that 4 alone here. This cube root, I'm just going to bring this to the power, so that what happens, it will become 1 by 3. Is it or not? Why? Because again we are using the same, this a power 1 by n axiom. Okay, so this is what I'm as like how we used here, the same thing I'm using here. But the only thing is, here we had square root, so it became 1 by 2. But here we have cube root, and this is coming as 1 by 3 in the power side. Okay, yes. So this is equal to, now come to the right hand side, and what should be our objective? This right hand side also we should try to write as a power of 4. This is what we have to try to do. Yes, okay. Yes, okay, fine. Now if you see it carefully, what happens is, like, this 32 is there, right? This 32, you just think like whether we can write it as in power of 4. That we'll just think for a while. So if you see 4 power 1 is 4, 4 power 2 will be like it will be 16, right? Yes. 4 power 3 will be, it will be like what? 4 power 3 will be 64. But unfortunately we are not able to get this 32 in force powers. So no issues at all. Like, we can't turn this to be force power. That is a little complicated for us. So what we will try to do is, we'll try to write as 2's powers. We can better do that, right? Why? Because 32 can be easily written as 2's power. Okay, yes. How we can write it? 32 can be written as 2's power. So it can be written as 2 to the power 5. Is it or not? So I can rewrite this as 1 by 2 to the power 5. Why I did this plan is, now left hand side you have 4 power. Okay, this 4 power can also be changed as 2's power. That's the objective. Okay, so try to change this 4 power as 2's power. So what will happen? This will be written as 2 square. So then I can write as 2 square means that 2 I am just bringing here, 2 power 2 by 3 into 2x plus 1 by 2. I can rewrite like this, right? So I hope you can understand this step, what I'm doing here. Let me just repeat it, what I did here. This 4 I'm just going to rewrite as 2 square. That's what I'm trying. Why? Because I'm feeling little complicated to turn the right hand side in terms of power of 4, but I felt very easy to write this as in terms of 2's power. So the same thing, since my right hand side has become 2's power, my left hand side also should be expressed in terms of power of 2. For that reason, what I am doing here is, I am just taking this 4 to be 2 square, and the 2 square is what is getting multiplied with the already there, the power which is there already. Okay, so 2 by 3 times of 2x plus 1 by 2. This is how we are writing, and is equal to, now coming back to the right hand side, we have what? 1 by 2 power 5. So what about 1 by 2 power 5? This we can rewrite it as 2 power minus 5. Why? Because I am just taking the reciprocal. If you take, what happens to the power will become the negative. Okay, yes, 2 to the power minus 5. We are getting it like that. Now the task is going to be very simple. Now I can very well equate the two powers, because left hand side also 2 raised to the power, right hand side also 2 raised to the power, right? Okay, so now I can very well equate it. So when we try to equate, we will be getting it to be 2 by 3 into 2x plus 1 by 2 is equal to minus 5. I hope you are able to understand this. Okay, I think this space is enough for us to work out and then get the answer. So yeah, fine. Yes, we'll proceed. 2 by 3 into, because left hand side my power is 2 by 3 into 2x plus 1 by 2, and right hand side my power is minus 5. So I can very well equate it like this. So what I will get here is 2x plus 1 by 2 is equal to, now I can bring this 2 by 3 to the other side. It will come like minus 5 into 3 by 2. Is it or not? Minus 5 into 3 by 2. So minus 5 into 3 by 2, because this is going to that side, it will become the reciprocal. Minus 5 into 3 by 2 will be minus 15 by 2. Alright, yes. Yeah, fine. Okay, I hope you can understand this also. Now yes, continue. So we'll have So we'll have, I'll just differentiate, okay, we have like 2x is equal to, now I can bring this plus 1 by 2 also to the other side, so it will become minus 1 by 2, is it or not? So it will become minus 1 by 2, so minus 15 by 2 minus 1 by 2, this is how we'll be having. So let me write it more clearly, since we are out of space, I'm just writing like this, okay. So my objective was to, I just wanted to show you the entire problem in one screen itself. That's the reason I'm doing all these things. So anyways, I hope it is not much confusing you. If you carefully following me, you will be able to understand the things. So like minus 15 by 2 minus 1 by 2, this is all you have here. And now what we can do next is, since we have a common denominator, we can just connect the numerators, right? It will become minus 16 by 2, and that's nothing but minus 8. So like we are getting 2x is equal to minus 8, and finally x is equal to minus 8 divided by 2, which is going to be minus 4. Okay, yes. So the last problem went little complicated. So like we are adjusting here with some technical steps like 2's power and 2's power we are turning it, and now we are equating the power, and hence we are getting the answer to be like x is equal to minus 4. And yeah, these are going to be the solutions for all the questions in question number 17. Here with the question number 18 here, and this is the last question of this exercise. Let's see what is the question. If 9 power n into 3 power 2 into 3 power n minus 27 power n, the entire thing whole divided by 3 power 3m into 2 power 3 is equal to 1 by 27, then prove that m is equal to 1 plus n. So it seems to be an interesting question, and this is the last question, so maybe the way they are presented to be the interesting question. So yeah, let's try giving this question. So if this is given, we have to prove that m is equal to 1 plus n. This is all we have to do here in this question. Yeah, we'll give a try. So first of all, let us start from what is given for us. So yeah, here we have a fraction, and this is starting with 9 power n, 3 power 2, 3 power n. So we have got 3 powers here, right? Okay, so in that case, we will try to write the entire thing in terms of powers of 3 itself, right? Okay, that will be better. That will be better, it seems. So we'll try to write everything in terms of powers of 3, and here also we have power of 3 here, but this is power of 2. We'll deal that later. And right hand side also we have 1 by 27. If you have a closed loop, this 27 can also be written as power of 3, no doubt, right? So measure all the expressions here, we can convert it as 3's powers. Okay, yes, fine. Now we have 9 power n we have. So in the case 9 power n, that can be written as 3 square power n. Okay, or in other ways I can even simply write it as 3 power 2n. Why? Because we have power of power only, right? So in that case, this will simply become 3 power 2n. So because 3 square power n, we will anyways multiply it. I am just doing that in a straight step. So 3 power 2n into 3 power 2 into 3 power n minus, now coming here 27 power n, we have again what here? We have got 3 power 3. This 27 can be rewritten as 3 power 3, is it or not? So 3 power 3, and we have n, so 3 power 3n, this can be written as 3 power 3n whole divided by, come here, we have 3 power 3m, that can be written as it is only, into 2 power 3. So I think 2 power 3 can be written as what? 2 power 3 can be written as 8, because there are no other powers of 2 available here. So I can better write this as 2 power 8, 2 power 3 as 8 itself. So this will be equal to, now coming to the right hand side, we have 1 by 27. This 27 as we planned, we'll write it as 3 power 3. Okay, all right. Yeah, okay, done. Now next what I can do here is, coming back here to the left hand side, we have this 3 power 2n and 3 power n, because we have both these terms containing 3 with powers as n's. Okay, n terms. Okay, so in terms of n we are having. So like what we can do here is, I will first multiply this 3 power 2n into 3 power 3n. Okay, sorry, 3 power n. So what will be the answer? Like 3 power 2n, if you just multiply it with 3 power n, what will be the answer? Like we will have the powers getting added up, is it or not? Why? Because 3 power 2n is there and 3 power n is there. When you multiply, because of they are having same basis, what happens? It will become 3 power 2n plus n. So that means it will simply become 3 power 3n into 3 square minus 3 power 3n. Okay, fine. You may ask why I am just leaving this 3 square 2. This can also be added here, right? Because this also has got the same base as 3 only, right? Okay, you may wonder, but I have a reason for that. We'll hold it. Okay, yes, 3 power 3m into 8. We'll have it into 8. So this is equal to, just continue, 3 power 3. And now what I can do in the numerator is, Now have a close look here. We have 3 power 3n into this 3 square minus 3 power 3n. Now if you watch here, if you just have a close look, we have got 3 power 3n and 3 power 3n. Both 3 power 3n's are there in the numerator. I can just factor out as a common term. Okay, now I will have 3 power 3n. Now what I will have inside will be like, very simply I will have this 3 square will be there, 3 square minus, here I have taken 3 power 3n out of 3 power 3n itself, so I will simply have 1 only here. Okay, so this is the reason I just left this 3 square as it is. In order to take this 3 power 3n from both these terms as a common factor out, I just kept this 3 square as it is without disturbing. Okay, alright, yeah, continue. 3 power 3m into 8 is equal to 1 by 3 cube. I think the space is enough here. I think the space went out, so no issues, we can continue here. So let's just continue the exact continuing step there. So we'll have 3 power 3n. Okay, 3 power 3n multiplied by, what about this 3 square minus 1? 3 square minus 1 is simple, 9 minus 1, it's going to be again 8 only, divided by, here we have 3 power 3m multiplied by 8 also. Yes, so see here we are getting 8 and 8 here. So right hand side we have 1 by 3 cube. So we can readily just cancel this 8 and 8 from both numerator and denominator. We can do that. So once we try to do that, what happens is like we'll be having it like this. So now we are simply left with only all 3's powers only, nothing else is there, only 3's powers are there. Okay, now what I can write is, I will just try to write this left hand side as 3 power, just see here 3 power 3m divided by 3 power 3m is there. Okay, so now what I can do here is I can very well write this as 3 to the power 3n minus 3m. We can write like this, right? No issues. So 3 power n minus, 3 power 3n minus 3 power 3m, because when we have same basis, when they are getting divided, what happens to the powers? The powers will be subtracted. Okay, that's what we are doing here. 3 power 3n minus 3 power 3m. Okay, minus 3m. So 3n minus 3m, we are just doing the minus. So here coming to the right hand side we have 1 by 3 cube, is it or not? So this 1 by 3 cube can be written as what? 1 by 3 power 3 can be written as, just bring it to the numerator position. So when we try to do it in the numerator, what happens? So this will become 3 power minus 3. That's what it will become, right? Yes, okay, fine. Yeah, we'll go ahead. So now what we can do is very simple. Now we have got both our left hand side as well as right hand side expressed in terms of 3's powers. Now I can very well equate the powers. So when we try to equate the powers, we'll be getting 3n minus 3m is equal to minus 3. This we can do. And hence what we'll do is like, we'll just take that 3 as a common factor outside. So when we try to do it, we'll be getting 3 into n minus m is equal to minus 3 here. And now what happens is n minus m will be equal to, I can divide, just take this 3 and it will coming here, as divided by 3. Okay, so minus 3 by 3, it will become minus 1. So this is what will happen. And now what I can do is I can just very well just interchange the positions of this m and this minus 1. I can do that, right? So I will just interchange the positions, that is this minus 1 minus m will go here and this minus 1 will come here, so that we will be getting n, this plus 1 is equal to this m, minus m goes there, it will go as m. Okay, so that means it's very equivalent, like it is equivalent that m is equal to n plus 1, because n plus 1 is equal to m is equal to n plus 1. Like this exact thing is what we are having here given in the question to prove. So we reached that step, exact step here, we got it. I hope you are able to understand the flow what we are doing here. We are just trying to do the same calculation, same kind of calculation. We are trying to express everything in terms of powers of 3 first, and in between we got 2's powers and everything, but that went in between itself, we got it cancelled, and we are finally left with powers of 3 alone. We are just taking both the things to be powers of 3, we are equating and then solving to get the answer. Like finally we got m is equal to n plus 1 or 1 plus n, whatever, both are same only. So this is what we are given here in this question to prove, and yes, we have successfully proved this also, and this is going to be the proof solution for our question number 18. Yes friends, I hope the method we use to solve all these problems is very clear to you, and any doubts as usual you can post in the comment box, and anything else you want you can again leave a comment here in this comment box. And if you feel this session to be useful, please give a like, and also if you feel that this would benefit any of your friends, please share this video to your friends also. Again, we'll catch up in the next session with some other interesting concept or exercise or anything. See you soon there. Thank you so much.